is stream number 26 in this series. Wow, we've been doing 26 streams and I'm not done yet. Crazy. So let's see what I have on the today command. Guiding where, yeah, that's basically it. Continuing to part the data analysis tool to Rust. Guide about where there's still to do and unwrapping the code. Actually, there's no more unwraps. So maybe I do update that command. Okay, to edit today. Or kind of where there's still to do in the code. All right. I was actually thinking about doing some refactoring. So this is in the data.rs. There's this bitstream stuff. So for example, I think bitstream handle is best put into bitstream. So that's what I'm going to do. I'm going to put it right there. Like that. Yes, Mr. Lovepickle, you're first once again. It's like, you're right there. Bitstream's subset deserves its own module, don't you think? Subset. Hope everyone's having a lovely Saturday evening and or Sunday morning or Saturday middle of the night, whatever it might be. Mod bitstream subset. I don't think we need to make that a public interface from the module though. All right. Gonna move this out. Along with its simple. Trying to make this easier to find things. So if I'm looking for bitstream subset, I'll now more easily be able to find it. Okay, get rid of some of. There was a request to lower the lights in my room, so now it's like I got this spotlight on me. Because there's a little bit of movie watching going on in the other room. Okay, delete these. It's sort of weird to be so like streaming in the dark except for that light. Looking at my picture and there's like weird shadows now. Ah, it's not too bad. Okay, delete that. Import that. Just got to fix up all the references here. All right, looking good. Cargo. Next. Test run. All our tests pass. Woohoo. All right. Let's do a little closer inspection. So, ingestion, source, bitstream subset is just bitstream subset. Bitstream is just the trait bitstream and bitstream handle. Buffered bitstream, we have this implementation of bitstream for a buffer. data. So we have, clear these out. We have data value. We have coercion to use size for data value, and we have this display for data value. Then we have data component. So we could split this into two. Why don't I make a directory called data? And in there have value and component. So in data, we'll have mod value, mod component, and then we'll have like a public use. You know, I actually feel better. Let's make this change now. Let's have mods first, then uses. Pub use component as data component. Pub use value as data value. Okay, and then we'll move this stuff. So all of that goes into value. Paste. And then ingestion error comes from the crate. Display comes from standard format. Error comes from error. That one's a tough one, so I have to type it manually. Log error. Okay. Then component. Cut and paste. This should be just value. Okay, and then this should be component. Hash map, bitstream subset, data value. Okay. Then I can delete all of these, and then it's just a thin shell around. So basically, this is how you take, if like you have two sub parts of a clean division, half and half of some module like data. I have component and value, and then I re-export them as if they were from the same module. And then these mods mean we're going to look in a subdirectory with the same name as the file, but without .rs, and then the names of the modules are that .rs. So here's component and value. And the reason that I do this as, kind of like the fact that if it's data / component, then component is the name of the principal class within that module. But when we re-export it out, we're not exposing the internal division here between the component and value, other than implied in the names, and attaching the word data onto it is consistent with the name of the module. So the idea here is to refactor the code so that we don't get too complicated. So I will group together related code together into smaller files, and then also some of the functions that are kind of getting too big, I think we want to split up. So data looks good now. Error is fine. Although I'm starting to think ingestion error, I guess because the library itself is called ingestion, and error was getting too overloaded of a term. Okay, ingestion's the big one, so let's skip that for now. Just look at lib. Yeah, so this is already following that scheme of having the modules first. I like that. So I should do the same thing for this one, right? I should have the modules first, then the uses. Yeah, I think I like that better. I'm going to go with that from now on. So, okay, these are all common test helpers. So ingestion, we need to break this up because like we shouldn't be seeing indentation to that extent, right? So let's do some scanning from the top. Also, another indication that the module's getting too big is if we have too many imports. So we have a context that's separate from ingestion. So that makes me think we ought to have a folder called ingestion. Actually, ingestion is the name of the library, right? Let's have, that means we can skip that next level and just call it context. Hold on, wait a minute. Wait. There's a top level library. Right. This is an ingestion context, right? Yeah, okay, so we are going to have a folder called ingestion within the library called ingestion, which is going to be kind of funny, but that's okay. That's okay. We can deal with it. So ingestion is going to have a submodule called context. And we're going to want to do pub use context and context. So we're going to move context down. Oh, it's not public. Okay. So then it's just use. I thought it was public, but yeah, that's right, it's not. Okay, that's all this stuff, right? Context paste. Okay, data component import. Span import. Hash map import. Error is the tricky one. Oh, they actually got it this time. Log import. Great. Okay, so that's a reasonable amount of imports. I like it. So at this level, it is public, right? That's good, because this allows me to make sure I have the right level of like, what am I trying to say? It has the right level of what's public and what's private. So this needs, that's public because it's used directly there. What else do we have? I see. So this makes me want to have a constructor for context. One that's new and one that's not new. Yeah, let's do that. Let's have two constructors here in context. So one will be called new something. And have this body. So that we can say self. Hey there again, Flask. Welcome back. Stream number 2. So I think this should be component boundary with no span. So this is like new top. Or new, how about we do new with new with composite. And we'll have the other one be new with part. So we need the composite data component boundary. What's the type of that? Option size. And then we remove that and leave it like that. Okay, and then back here, we would say context. Oh, hold on. We have to mark that public, otherwise we won't be able to see it. New with composite. And here we do this component with ours component and the boundary, right? Okay, and then the other constructor, this one. This is new with part. Maybe instead of new with, it should be from. Or 4, maybe. Context 4? That might make more sense. So I think I just need an immutable reference to for the context for the composite context. And this being the part. Composite context boundary. And we need a path. Okay, and then back in here, it's just context new with part. That. And then this for the boundary. And the path last. Oh, it's just context. Yeah, here we go. I am back on Toulouse. How are you doing? I did just go for dinner. Also, how should I say this without doxing myself? Someone in my family was gonna be on in a show, so I took some time out to see if I could spot him on screen. But I wasn't able to see him, so because there's too much going on. Mrs. Raimu's there live, and I was looking to see if I could see it on TV, but I couldn't. Even she wasn't able to find it. So she's somewhere there's a lot of people, and my son is one of the performers. Yeah, it was fun. So I took out some time for that. Yeah, but couldn't find him. That's okay. Okay, so this is because path is private, right? Yeah, so I basically needed to get re-energized, get some food, take a break, but I did intend to come back. And I think I might not have said it too clearly in the last stream, but yeah, I'm like, I'll be back. Just need to get some get refreshed and all that. Because this is used like that all the time, I'm wondering if I should just make it a function of the context. So the idea would be that maybe the context would do a diagnostic with this internal, it'd be internally used, and it would glue it with some string we pass in. The problem is if I have a function called here, it won't remember. Well, it'll just look like it's always coming from the context. I guess that's fine. Yeah. What to call it though? Error diagnostic? Report error? Uh, log error? Log error. Okay, so this would be the error, right? Let's make it so that it's easier to call. So this would be like maybe generic on some t where t is as string, as ref string. This would be the message. I like to use full words. So message. Okay, and then the error here would be two things. That is self, and I need to put a self here. And then the second thing would be message.asRef. Actually, isn't it as string? So it's not as ref, is it? Hold on. How come I can't see the tab I'm on? What's wrong with you, Chromium? Chromium's wigging out there. Recently closed. Can't I like oh, there we go. Okay, I think it was just stuck on something. Docs. That doesn't come from a trait? I thought it did. Okay. For some reason, I thought that came from a trait. But asref definitely does. The trait method. Maybe I do want asref. Use span, and yeah, I can do that. Okay, the reason to do that is then I don't have to do this outside, and you can actually pass an existing reference, and it won't do anything extra. Okay. So yeah, this would then be context log. Okay, can't call log error because I didn't mark it public. I need to mark that public too. The log error, and then I just need to say format needed. There we go. And actually, are we always doing that if we're logging an error? Then it's more than just logging the error, right? It's on error, right? We're going to mutate self. Okay. Yes. I can do the same thing down here. And here I'll do that with the format thing. So context.onError format. And that goes in here without this in front. Nice. Oh, let's have warning or something. So an alternative to on error that's like warning. On warning. So it's just this, but with warn. Okay, and then context on warning. Format. Paste. Get rid of this thing. So I need the arguments, don't I? This format name. So one aspect of this is separation of concerns, because ingestion really shouldn't care about the fact that we have this current statement span prefix, right? Also, it kind of collects into one place the fact that we're doing that. In fact, I might even want to do this gluing of two things together with the prefix in a common function that both of these leverage. Although I'm kind of leery of having multiple formatters. So yeah, there are all these places where we're doing this, and the fact that I moved context down and now everything is private by default, and this is going to flag it as that's private. It's like, well, yeah, that should be a concern of context and not of the user of context, right? This is on an error. Format. Paste. Okay, getting there. That should be public. Handling of the path, right? So we can have context new part do this part actually for us, and then I don't have to pass in path. So we can do that right there. Oh, hold on, we lost it. Cut, browse, paste, go back, cut that part out. Go to that, remove the path. So this is composite context path clone, and then we have the path. See, much cleaner. So when the functions start looking cleaner like that, then I'm liking how it's looking. Yeah, I totally love this. This context we're only creating so that we can do ingest in context, right? Actually, you know what that makes me think? That this should move into ingest in context because we're only using it to use with this. Oh, wait, but there's a reason why not to, because we have this, right? Yeah, the problem is there are two different ways to construct the context. And this is where I got stuck on a week ago. If you guys were there during that one of those frustrating streams. Ingest in context, the context is built differently depending on if it's this should be called like ingest composite, an ingest part. If it's a composite, then we make a whole new context. But if it's ingest a part, we construct a new context from a previous context, like a subset of it. Yes. But I do notice one thing. We don't use the context after ingest in context, and it just returns the composite always. So we could just have ingest in context return the composite only, right? So we could just have this one return the data component. And it's just going to return context composite at the end, right? Only price I have to pay are these early returns. But I can make a wrapper for that. Hold on. Let me make a wrapper for it. So if ingest in context further wrapped another function, which returned the data component, and then no, which didn't return the data component. No, the outer one does, but the inner one doesn't, right? And we'll call the inner one something else like temporary, like inner or something. Then, and this doesn't return that, then we let it handle the context like that, but then this one would actually own it, and it would call the inner one. So like this, it would say ingest in context inner. Exactly that. And then it would return context.composite. Then this could remove that line and this line. And remove the mut thing completely because it's owned. And then I could actually collapse this down. So this inner context is just this part. So that fits right there. And then it's just a one-liner. So really what it's doing is decomposing the component with the arguments into the component and the arguments, and then calling something else. Yeah. And this thing can do a similar trick, I think. Let me hold off on that because I want to fix these other errors first. Right, we're always doing this, right? We're always adding to the path. So let's make a method of context do that. So like add to path. Format. Well, next. Actually, I don't know what type it is. Let's just assume that it is string. Okay, and then this is context dot add to path. It is a string, sort of. It's could be dereferenced as a string, right? So it works. Cool. Okay, so I need another thing that sets the current statement span. Set current statement span. All right. Oh, it's an optional. It's always some span, right? We never set it back to none. Yeah, so this is just set and then that. Okay, I was only using this prefix because we're gonna end up doing an error. Which, actually, hold on. We're always setting the composite error. Yeah, this is gonna be what? Context log error or on error. Format. This part. And this one's just error. So we don't need the prefix anymore. So for that, let's just make a method called path that gives us the path. Pub function path self returns a reference to a string self path. Okay, one more. Boundary. I guess we are having it return an option usize. Copyable, right? So self boundary. Okay. Okay, so it doesn't cannot borrow it as mutable because also borrows immutable. Immutable happens here. Wait, composites public? Oh, hold on a sec. we're using self here, right? Using self anywhere else? This is a problem that we're borrowing the format, but then we're calling something that requires exclusive access. Conceivably could change format, but uh, like I could make a copy and but we really only need to borrow it. So an alternative is to move all of this into the context. It's just that we would have to pass the self formats. Self is not used anywhere else. Oh, it's used in execute statements. Okay, we're making a clone. And then we're borrowing it there. When in doubt, clone it all. When in doubt, clone it out. Oh, cool. So I can put that in line. Nice. And then we have some imports we don't use anymore. All right. Refactoring step done. Nothing broke. Okay, from the top. We need a blank line there. I think I do want the elementals to be in their own function or their own module. So let's make under ingestion elementals. Okay. Yeah, and all these functions go in there. And these all have to be marked public, right? And then we need to import all the things we need. That's illustrating a little bit of a stretch. The fact that it's not public, so we had to reach into super to get to it. Okay. I don't think we need to say self here. I think that's implied because that's one of our submodules. So I'm just going to do that. We need a blank line there. Okay. Oh, this doesn't go here, does it? Doesn't that go with data? Or actually, where is this used, really? Okay, it's part of the public interface of ingestion, so I guess it stays. Error callback, ingestion, and then here are the implementations. New, on air, ingest. Wait, it shouldn't be called that, should it? This should be like with on air. Or with error callback. Ingest. Ingest part. Ingest in context. Yeah, so I need a new name for this. That is a thin wrapper for that, so that all the various return paths will give me the composite on the way out. I'm terrible with names. I don't know what to call it. The only difference between these is this returns the component and this doesn't. So what if I just say this is in context and we rename this one to be like it's like ingest composite or ingest component. And this is ingest in context then. These names are too similar though. That's a problem. I mean, these are basically the same, only it's this if we have arguments and a context. Now you both have to have a context for both. Hold on. Wait, then why is this? Oh, this is borrowed. Never mind. Probably because this eventually, yeah, this eventually will end up borrowing that context. But that doesn't need to be borrowed, right? Yeah, this doesn't need to be borrowed anymore. Yeah, these names are bad. Okay, this is okay. Ingest component with arguments. Very clear, right? This is ingest a part. Why is it called part? This should be ingest in context. So what do I call this one then? And this one. I don't know what to call these things. The computer doesn't really care. It's just me who cares. Really don't know what to call it. There's also this little point of fragility that we had to clone. Should these be members of context? Really, it's just getting access to the data. Wait a minute. Then shouldn't these be methods on data component? I think they should be because the component is the one that whose bitstream. Yeah. Why are these not methods of data component? Okay, let me move that in a little bit. There's no reason why it shouldn't be. Then we don't, because then we would be able to get rid of that. And that's the only thing context is used for. Yeah, I shouldn't need the context if the only thing I need is the component out of it. And it's self-describing. Okay, yeah, we're gonna fix that. What stood out to me is we're passing the context for all of these. And it's like, well, then those should be more closely bound. But then I looked at it and I'm like, well, the only thing in there we use is the data. So it's really just, this is a wrapper only to get to the data. So yeah. Okay. I'll fix that in a second. What I really want to get is these names more improved. And this is called from where? Maybe I don't need this function at all. Yeah, why don't I just put it in place there? It's only called from one place. So I would take this, go to where that's used here, and put it in place. So if that's what it used to be, and this is what that expands to, then, and that goes in place of these two, and context goes in place of context, then that's just that. Yeah, there's no need to have that extra layer. It's never used, so we can delete it. Okay. We have one fewer thing to make a name for. So there's ingest. Good morning, good evening, Nightshade dude. Wait, good morning? Did you just jump to the other side of the planet? I thought you were at TwitchCon. Did you meet up with Prime? Ingest component. I guess these are good enough now. There's ingest, which is the top level one. Ingest component is really just a wrapper about ingesting context, because this consumes the context, and it's like within the context we do that, and this gives us back the component. I think I'm gonna go with these names. Just got home, yeah, had breakfast with them this morning. Nice. Hope you enjoyed the meetups. If it looks like there's like shadow over here, that's because I have no lights. And that's by choice, because someone wanted to watch a movie right in the next room, and I don't have any way to block the light out from them. Okay, yeah, now that I've cleaned up these names, I've identified that these functions should actually be methods of data components. So let's move them. These elementals all get to be moved. Cut, and we go down into data component and we paste them here. Paste. Okay, then we don't need this anymore. We're going to delete it. Then we got to fix up a bunch of things, right? So elemental bit. Well, let me repair the other side first. These aren't used anymore. That module doesn't exist anymore. So when we call them, it's really context.composite.elemental. I really should have done that with multi-cursor. So let's try again. Word, context.composite.word over letter, word, delete. Wait, nothing found? No method UI found? It should have been found right there. Oh, because it needs, no, it should find them. What the heck, computer? Define impl for the type data component. Use associated function syntax instead. Oh, right. I have to repair the signatures of these functions. So they all have to have a mute self instead of context. Right? Yeah. I was confused for a moment. I'm like, how come you don't see them? The last thing I'm gonna do is rename them, because elemental yeah, they can be renamed. Hey there, Patatas del Papa. How are you? How are you this fine evening / morning? Okay, so it's not data, it's now self. Error can be imported from log. See, now it looks better. See, I knew that eventually, I knew that something was wrong there. Now, it actually makes more sense because we should have a lot of selves, right? Yeah. And not have to reach through another data structure to get to it. All right, I'm happy with this. And one more. Okay, now make sure I didn't break anything. Still good. Yep. Despite my best efforts, I haven't broken anything. So now let's rename this to something more reasonable. This should be like ingest or parse as bit or ingest as, yeah, okay. Actually, I don't know if that's really an improvement. It's probably not an improvement. Okay, so in common custom format, I think this ought to just go into its own method, and then the ingest in context would be a lot smaller, right? So this should be like ingest custom ingest part as custom format or something like that. So let's refactor all of this, extract into function, and we're going to call it ingest as custom format, user format, ingest as non-elemental, ingest non-elemental. I like that word elemental. Or we can just be lame and call it ingest as common or custom, because we have ingest as, and then if someone reading this is like, oh, as something specific or as something custom. What's that doing here? Why is this returning a control flow? Oh, because I had some breaks in there? Interesting. I didn't know you could do that. Is that like defined in the standard library? It is. Huh. Used to tell an operation whether it could exit early or go on as usual. This is used when exposing things where you want these to be able to choose whether to exit early. Huh. So it's a normal thing then. Okay. But do I want that? That's a consequence of refactoring something out that had a bunch of breaks in it. Or it had a bunch of early returns in it, right? Maybe I don't need that. Like continue, it's just gonna fall through, right? It's just gonna fall through that match. So why do I care? Shouldn't this just be that? Shouldn't it just be that? We don't have a control flow. Just return. I guess it was being conservative? Maybe it's just the way I wrote it. I don't know. Yeah, we don't need that. Don't need no control flow. Cool. It's nice that our tests run in less than half a second too. Okay, so we have ingest in context, ingest as custom. So I've been putting context up front. Is that a mistake? Here it's backwards. Let's put it up front. All right. It's looking a lot nicer now. This is all chopping up the arguments, right? I think that this should be pulled out. Refactor. Why did it take it all the way out like that? Actually, this makes me think it should be a function of the context. Again, with the control flow, I don't need that. Oh, no, I do in this case, right? Hold on. Undo that. Yeah, this has early returns before the execute statements, right? Okay. This has the side effect of setting an error, right? Yes. Okay, then I think I know what I want. I'll just manually refactor this. I want to put this in the context then as a like parse argument, or I guess we're ending up evaluating expressions, right? No, I'm not even doing that. Oh no, well, am I? No, we're not even, we're just setting values. It's like match up arguments. Pass arguments is what it should be. Pass arguments, that's what I call it. Well, it's not pass arguments to the context though. It's populate arguments or something. Populate composite arguments. Okay, and being a member of context, then we have these context things. We should have mute self. Context is replaced with self. Okay, and then we need format arguments. Format name. So we need the format. Why are we calling it? Oh, I know why I'm calling it format, because it is a format. 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 Okay, and then the arguments. That was a slice of data value, right? Or optional data value. Okay, and then yeah, that's self. Okay, and then let's just have it return a result. One of these like empty results. Just so that I can say that's error. And this is okay. Okay, we need an actual. Wait, no, we don't. What's the problem there? Expected standard option found a reference. Oh, right. We're actually consuming a vector here. Forgot about that. Okay. Now that it's in place, we can call it from here. So that's context dot populate with arguments. So we need the format and we need the arguments. And then if it is error, return. There we go. So now it's a much shorter function. We can actually read it. We look up the format, then we populate the arguments, then we execute the statements. And shouldn't context go first? Oh, wait, no. Statements is the principal, right? Yeah, okay. I like to put the principal argument first. Although it's backwards from the other things right here, right? No, it's not. Context is second. Context takes the back seat. Do we actually use self at all? We do it to call execute statement, but do we use self inside of here? We do for part. Do we use self here? We use it for build part and ingest component. Ingest component. Ingest custom. Yeah, we need that self again. Okay. That's the reason why. So these have to be part of the ingestion because formats is foundational along with error. If we do an error statement. Okay. I'm cool with that. Okay, so statement. I think it would be best to break this up in every match should have its own function. In fact, I think statement should have its own module in which we put those functions. So ingestion will have a module called statement. So back in ingestion at the very top, we do a mod statement. Okay, and then I can start refactoring these things out and then. Or better than that, these to-dos. Hold on, I can just take all of these in one fell swoop and just copy them and we'll make functions out of them and then we'll change this to, yes, the execute part statement's already been refactored out. So put that there and then go back and take execute part statement completely out. And along with build part. Actually, this is probably going to be another level of function, isn't it? I don't even think this needs to be a method of ingestion at all. This definitely does, right? Yeah. Wait, taking that out and we're putting it in statement here. Okay. So definitely need to rework this. So this is impl ingestion. But we don't care about formats at this point. So it's just ingestion inferred lifetime. Okay, and then we have public function. Actually, it's just this one down here, execute parse statement. Cut. Paste. What's that? Unclosed. Of course it's not closed, because I haven't closed it yet. Close. There. Port from the crate. Okay. Okay, so it's in multiple places. Save that, and does that solve this one? Yes, it does. Import from super. All right, we're getting there. Build part. This is the one I'm not sure it actually needs to be in self. Let's see. Self. Yeah, I don't think it needs to be in self. So we're going to get rid of it. It's a free function. Build part. There we go. Build part from the statement in the context. Map it to ingest component and then unwrap or else it's an error. Hey there, Raticide. New gun sip. Cheers. My lighting seems a little weird just because I'm mostly in the dark except for the spotlight. Okay, so that's execute part statement. So these don't exist yet. We'll keep the originals, but the ones that I do need to add here. So I need to turn this into a pub function execute return statement. Okay, looks like I actually don't need self for this one. So it just takes a context, and I don't even think it needs a statement, does it? Actually, I think it does need a statement. It has an expression. Right. So instead of a statement, it's an expression. And that expression is probably just expression. That and that. There we go. Okay, no break statement, but we do have an error statement. And so that is similar, right? Yeah. This much of it. There's an expression, there's a context. There we go. There we go. The formatter's working again. How have you been doing Rust long? About 3 years. So the first thing I did in Rust after learning it was I tried porting the game I was working on to it. And that was going so-so, but the game was really greatly in need of refactoring, and I made the mistake of trying to refactor it and port it to Rust at the same time. So that was sort of a disaster. And then I got a job, and then after working at the job for a while, I kind of figured out what I could do on stream again, and then I made this. The firmware of this keyboard is all in Rust. It's the Rusty keyboard. And that was last year's project. And then I got some embedded firmware experience in Rust, which is cool. And then since then, I've worked on learning graphics libraries, and now I am porting a data analysis tool to Rust. So I like to pick Rust projects because I like the language, and I'm trying to pick like different projects, like from embedded to graphical to data-oriented ones, to get like different experiences. Use WGPU a fair bit? Yeah, WGPU is awesome. WGPU, I probably still have a command for it. Yeah. Oh, actually, I have to go. I'll be right back because I have to turn off our Roomba. It just started running around. Probably don't want that Roomba going around when we're watching a movie outside. Okay. Oh, you want some food? Yeah, I had to send the Roomba back home. Don't know why the dog started barking. Yeah, and the cat. I had to let the cat in. I had to figure out where the dog was barking. I had to turn off the Roomba. Okay, but we're back. Yeah, so I was playing around with a bunch of libraries. Also played around with eGUI. And what was the other one? WGPU, eGUI, full tick. I'm missing one. Hold on. Well, we can open the project to see what it was. New window. Make it big. File, open recent. I feel like I'm missing some files here. I guess not. Okay, Dolly was a little one we were playing with. Oh, WInit. That was the other one. Do I have a command for that? That might... Yeah, I don't have a command for WInit because it was sort of a small library. I already knew full tick, but WInit gave me an alternate window top layer library, and then there's these integrations with between eGUI and various things. Yeah, and WGPU. Oh, Rapier 3D for physics engine. And Rodeo for... That was for audio, I think. Yeah. Yeah, that was fun. I worked on that for a couple weeks. And then I thought, hey, I'd like to work on this tool that analyzes data that I had to put on the shelf because occasionally I get like an opportunity to work on something off to the side where like, you know, that having that data disintegrator would really make this job a lot easier. Okay, so, oh, hold on. We don't have access to the error callback, do we? Well, we can let it be borrowed here. So on error is a mutable borrow to an error callback. And then we just do option. Then we can call it, right? Wait, what's the problem calling it? That's why I have an if-let. What's the problem here? Is it because I called it something else? No, that's not it. What's wrong with this? What am I not seeing? Is it because it should be on the outside? Do you need to deref it? Is that why it's not automatically derefing it? I didn't have to do that before, but you might be right. Expected function called, why is it finding an option there? That's why I have this if-let. It's almost like there's an extra syntax thing that I'm not seeing. What if we call this X? Found an option again. But that's why I did an if let sum. What is it I'm not seeing here? Oh, is this already an option? Oh, wow. So I'm silly. It's not that. That already is an option. Okay, I'm just being dumb. I forgot that the error callback. Okay, maybe that shouldn't be an option inside there. Maybe it should be outside. Otherwise, or I should call it optional error callback, right? What if I do that? Call this optional. Now it's now we can see that it's baked in. That makes more sense to me. Yeah, I didn't have to deref, and because the name was poorly chosen. I'm notorious for making bad names. Whoop, I didn't mean to pull that up. Okay. We're just importing all the things that we need. Bitstream stuff. Okay. Cool. So now that I have various parts here, I should be able to use them from here. Here. So that we already have. Now here, this should be context.execute. Is it not context? Where did I put it in? Is it part of self? It's part of self. Self execute. Why is execute return statement not on there? Did I not make it public? It's there, public. Weird. Oh, because there's no self on it. Okay. So then it's self execute return statement expression context. Okay. Cool. I guess I didn't need a semicolon there either. All right, and then this one is self execute error statement. Actually, here's where the self. Okay, yeah, that's why. This one could use the self, and they don't have to do this. So yeah, mute self. Get rid of that, and this becomes self on error. Okay, that makes more sense to me. So this is self dot that. Okay, all that goes away. Cool. So yeah, I want to keep this one like one-liners that they just branch. Okay, we're still passing. Let's get rid of some of these warnings. Yeah, the goal is sort of to cut down on the imports by kind of separating the code into pieces. That should facilitate that, right? This is a lot more readable than it was this morning. Part statement, return statement, error statement, and then build part is just a separate thing because it's used. It's just a small piece of executing a part statement. And does it make sense for it to be a free function? Or should it be something from context? It kind of makes sense because context is mentioned so many times that it should be a method of context. So it would go here somewhere. This file's already kind of big. I'm not sure. Let's see what it looks like if I were to take it out and go to context and do build part. So build part would have a mutable self. And so we're building a part based off of a statement. So everywhere we have context, we would want to say self. import some things. Okay, and then back here, it's just context.build part from a statement. Public. Don't need to do that. Don't need ingestion error. It does cut down on the imports, that's true. Thing is, I'm worried about this file getting too big. It's already 280 lines long. Also, there's too much indentation here. I think this does need to be trimmed down a bit. So what are the steps in building a part? We get the actual arguments. We get the bound from the statement. Then we look and see if there's no bit stream. We make sure that there is not a bound. Otherwise, can't set a bound without a bit stream, and it's an error. If there is a bit stream, then we have to construct the new bound from it. So maybe this should just be refactored out. So this is like find bitstream subset given a bound, right? Evaluated in the current context. And it can return an error. Let's just manually refactor this. I'm a little bit scared of what it would do if I automatic refactor. Maybe I shouldn't be scared. Let's see what happens. What's the worst that could happen? It actually didn't do that bad a job, although it's got a result with an option and then an internal result, which is not good. Yeah, it messed things up. Let's undo that. It was a little bit too aggressive there. So we'll just copy this. What are we going to call this? Like make bitstream subset? LMNO. So it would go right before this actually. Function make bitstream subset. Do I need mutable access to self for this? I don't think so. Immutable access it is. And then we definitely need a bound, which is an expression. And we'll see what else we need. We are generating a result. If successful, it's a bitstream subset. If we fail, it's an ingestion error. Paste. Okay, I gotta clean this up now. Okay, maybe it's not, maybe it doesn't start its life as a, oh, it's an optional expression. Okay, we do need an origin. Which is, I think, another option, right? No. It's another bitstream subset. Okay, and then presuming I just do that. Oh, there's no sum there? Wait a minute. How does this use in the original context? Okay, so it's always sum. So I can take the sum out of this, right? I can make it an not an option. We either make one or we don't. All right, that makes more sense. So do I even need these returns now? I do because these are early returns because we couldn't construct a limit. The limit might still be none, or it could be something. Actually, can't I do a try and get rid of that? What is, I would have to do the map error though, right? Actually, doesn't try do a map error automatically? So then if I do a try, limit becomes an option use size, and then I would just match that, right? Yeah, then we just reduce this down, right? To none and some. And then that isn't that just a map then? Yeah, this just becomes a map. So dot map limit to that, right? And then we get rid of that. Maybe not. Then it's just limit. I feel like I'm missing some punctuation somewhere. What's the error here? Missing arm none and some. Oh, we don't need a match. There we go. It needed me to wrap it Y. Option, there's still a result in there. Shouldn't it be like unwrap or? Or, wait. This one, after the and then, what do we get? We get an option use size. This isn't really mapping anything, is it? This is just saying, if there is a limit, then do these extra checks. Seems it's an and then because of the error return. Yeah, but then I have a try here, an early return, so that should strip off the result. And it looks like it does, right? It's just an option use size if it gets past there. So if it's an option use size, the map should map use size to something else, right? Close that. It thinks the type should be result. Okay, what if I just terminate this and I do limit equal limit dot map? Is there another result in here somewhere that I'm not seeing? Oh, it's this return here. That's what it is. Yeah, that's it. Yeah, you found it, Patpatas del Papa. You now have 16 points. Congratulations. So that's another early return. So then don't I want to do an and then? And then map? Wait a minute. Yeah, wouldn't it just be an and then limit? And then I move this one down to here. And then this one is an okay limit? Question mark? And this is an and then. No early return. That's an option. Oh wait, no. Scratch that. It's a result option out there. Now I'm losing track of what I used to have. Let me back up. See what I used to have before I messed with this. Yeah, it was originally a match. Okay, let's go all the way back out. I thought I was being smart using the question mark operator, but maybe we leave it like this for a second. Make sure that let's just make sure this works, and then I'll try again. So this was my attempt to just do this. Does it be self? Yeah, self dot that. Origin bound. I think that's right. And whatever it returns, we return. Except for it's not a result, it's we'll have to fix this, right? Because right now it is returning a result, not where it's in the context of it needs to be an option. Oh, I think I know what to do. We do a question mark because this thing takes a result. But I still need it to return an option because it could be none. Which means that down here it's an okay sum. And what's wrong with, I guess, because we have all this extra stuff here now? Delete it. Okay, let's just make sure it builds and runs. Good. So now we can refactor it. Okay, here we go. So my theory was we could use the fact that we have result as a return value to early return from here. So that would mean I wouldn't need this. So let me at least do that. So we still have the match, right? But doing that means we're matching on, we can drop this clause here, and I should be able to drop the OKs off of here. Right? That should work. Okay, little steps, right? Little steps, and then we'll do bigger steps. So the next step would be, I saw this and I'm like, huh, isn't that the same as a map, right? And I think it is, because we get, actually it doesn't say what we get here, but I think this is an option limit at that point, right? Option usize. So can't I just do then, oh right, here's where I went wrong. There's a return. If I put this inside of a map, then that's a problem. Yeah, then return error makes it not a map, sadly. But isn't there a way we can like do another one of these early returns by doing it's not an and then. An and then makes it an option, but we want it to be a result, right? It wouldn't be okay or else. Or maybe it would be. Wouldn't we just map it into an error and then early return it? Yeah, wouldn't we? I could make a map and then just wrap this in an okay and then early return it out. Yeah, why wouldn't that work? Map limit, right, to this, and then this becomes an error, else it becomes an okay, sum limit, and then we early return it again. That should work, right? It didn't work. Why not? Oh, because there's a match there. Right, the match goes away. Did that didn't strip off the error. That should have. Wait, if I don't have that, then what is limit? Limit is an option result option. How did that happen? Oh, I see. Yeah. If it at this point it's an option usize, and if I map that, then it becomes an option result option. So I don't want this. I want it to do um if it's none, it stays none. If it's some, it could turn into an error. But then we want to early. So that means I want to put it into an okay and do an and then, right? Dot okay. And then, right? Why can't I put an option into a result? No method okay on an option. Really? Oh, it would be to, okay, this is going to look weird, but we put that all around it and then. That's horrible, but yeah, then I can do an early return there. No, it's still an option. Because why? That's a result option. Oh, because I want to early return. No, I don't want to early return there. Result option. Yeah, I don't want this then. Okay, I'll figure this out at some point. This might take me a while. Near mind, I use transpose again. Map. I'm using transpose way too much here. There's a code smell. It smells like transposition. That's the name of my new band. Smells like transposition. The option and then, I guess I'm not used to doing that. Option and then source. None stays none, but sum goes through a function which can generate a new kind of option. So a sum could actually turn into a none. Otherwise, it's the same as map, only map would return a u, not an option u, right? With map, a sum stays a sum. A sum never turns into a none, but with an and then it can turn into none. So this is saying the bound could turn into none. I guess because we evaluate it and it could be a nil. Actually, that's exactly what it is. And we have to... This reduced to 1. I think that's because I used to have a flatten. There are two option paths, though. You could have either have not a bound or you could have a nil bound. I think what it is, I used to do a map and then I did a flatten. That's why I said this. So this really isn't relevant anymore. Actually, we should say action evaluation is fallible. Let's see. Evaluation of some bound may yield no nil, none. So we have to bring it out. So this is the reason why we use and then. it's fallible. To bring it out, we do transpose. And then I'm transposing again because I want to put I want to take the result out. Wait. Result option. Why am I doing a transpose there? What happens if I don't do that? Expected an option. Oh, it's hiding the result inside. Because and then expects an option, but that's not an option. It's a result of an option, and transpose hides the result inside, and then this brings it back out. Oh, that's ugly. Is that the reason why I'm running into problems? Anyway, yeah. Maybe I shouldn't try to do this so functionally. This is maybe an example that would be better done imperatively, right? Or, I could just do early returns. So I can just early return that, right? And then it becomes an option value. So then we map to, yeah, why can't I just map directly to usize try from then? Transpose it and then out. There we go. Exactly. And then it's an option again. Don't want to just do another transpose and out again on this? No. Yes, actually. The answer is yes. I do that. No, it's limit. Crap. This isn't right. It shouldn't be and then. It should be like map to a result like this, then transpose and early out. Yeah, that'll work. It's just really odd that I have all these dot transpose question marks. Is that normal to do it? We got back to your original message. In my mind, I transpose again, mapped to OK, and then transpose to get result. So I got to the same conclusion you did then? Is this the way you would do it? It just looks ugly to me, and it's hard for me to make sense of it when I read it. No, so you have a better idea. In your mind, you use transpose again, map to OK limit, and then transpose to get result option, which is what I did, right? Use match and result, really? I guess this is the no match alternative. You have no this is better than comment. Okay. There's got to be a way to do it better, though. Oh, and this isn't even indenting correctly now. But it does build, right? Yeah, it built. So I'm defeating the indentation probably with this huge string, right? So we were going to use the trick that someone taught me where I do a backslash enter. It's not indenting it correctly though. Oh, it is, but the formatter's busted for that second line. Okay, that's a problem, right? Like, if the indentation of the outer thing here changes, this one won't change. Better than nothing. Let's just continue. if I can't think of a better way to write this without transpose, I think I'm just going to reduce it to imperative. So we like do it one step at a time. And we would have these early outs as we go. Does this insist on putting that in another line? It kind of does, yeah. Actually, the alternative to doing the question mark map would be then an and then, wouldn't it? I'd still transpose. So like I would do and then. That's the same, right? No, it's not. Yeah, because we have to double it. Okay. Hey there, Stripe Monkey. I'm trying to like, I got this working, this ugly chain, and trying to like either clean it up, or if I can't clean it up, I think I'm gonna break it up into different steps with names. Because it took me so long to get this working, and the fact that I need this huge comment, this is just too ugly. I'm trying to break this up. Break this down or simplify it. So we have an optional expression. If there is an expression, then we need to evaluate it. Evaluating it could give us an error. But I need to transpose it back to an option error because of and then turn it back into a result option so I can early out the error. So we're back to option again, which lets me map to do a try from. Try from turns it from an option to an option result. So we have to turn it back to a result option and then early out again. So we're back to an option again. And then map, if it's something, then we have to map it to like do a bunch of stuff. And in that could result in an error or not. So again, it's going to turn from an option to an option result, transpose it to result option, and early out the result. Is this normal to have these transpose question marks to early out the results that we get in a chain of maps? Because that's what's happening. Every time we map, we have something that's fallible. Every time we map, right? And I'm solving that by doing a transpose early out. Is that gross? So maybe the right thing to do would be that every time I'm tempted to do a transpose, I break it up into I do something more explicit, basically. Right? So there would be one or maybe two, yeah, 1, 2, 3 steps to this, right? So let me try to do that. I can do that step by step by doing this, and then I say beginning of line, let limit equal limit. Why did it add a transpose there? I don't know why. Well, let me just copy from here. Okay. And then again, semicolon. And then we basically repeat this line here. Okay, now I've broken it up. Now maybe I give them names that make sense. So this is the original bound, then what is that? Limit is this name is correct, but this name and this name are not correct. So what is this? Optional value. So this is an evaluated bound. Or bound value, I guess. Because bound, like the word value has special meaning in my project. It means a data value type. Or this. That's a value to me in this project. So yeah, then we always want to try to coerce it. So this is like bound integer or bound size, right? Whoops, how did I get there? Try again. And then we take that bound size and we apply it to the it's not really a limit. Well, I guess it is a limit. Right, actually it is a limit. This extra step is really just doing extra tests, right? So maybe the problem is I don't really want to do a map at all because really it doesn't change. These are just extra checks I want to do, right? Yeah, this would be something like if let sum limit equal limit, then do extra checks, right? We do all of this, and if we get out here, we're going to return ingestion error. And I don't care about the else. That's probably what it should have been all along. What's wrong with that? Option result. Oh, error. There, that's a little bit better, right? Maybe try to add more? Question marks? It's actually a lot better already because that's doing what it actually should have done all along, which was this is checking to make sure that, so I should have a comment for it. This is checking to make sure that we don't what am I trying to say here? Yeah, this expect here, this is expecting that if we had an origin, we should have a boundary. If we have an origin, then the context should have a boundary. So where limit comes into play is this inner bound can't blow that boundary. So yeah, check to make sure the limit doesn't exceed. Well, the bound, using these things interchangeably is hard. Limit doesn't exceed the bits, the subset, bitstream subset won't exceed the boundary, the current boundary set in it won't exceed the current boundary set in our context. That's worded poorly. Check to make sure that the bitstream won't exceed the current boundary. That's probably good enough because current, the word current to me reminds me of context, which is the self. Where was that? Self right here. Self boundary. Okay. Then what are we doing here? Why bother transpose, right? I should probably there's probably an easier way to say it, to get the bound value from the bound. I think it's this and then thing, right? Bound is an option. So why don't I map it? I can't map it because that uses a function that doesn't let me early return. So I really want to turn the option into an option result and transpose it once. So why am I doing this crap? Because this returns me a result option already. I shouldn't need to transpose this. why don't I just say that this equals that and to be done with it, right? Oh, because bound might not be some. Shoot, what do I do then? I don't want to have to transpose twice. I mean, this is okay because we know that this is an option and this is fallible, right? So it makes sense that if there's a result inside, we want to get it out and return early if it's an error. Maybe I just assume that's the same deal here. Or maybe this should be map. Actually, it should just be map. No, but then there's a double option. How do I do this then? How do I get like not an option back out? Oh, it's because there actually is a double option. So I want to transpose and then flatten. Flatten the option. So that's maybe more appropriate, right? So this gets the error out and returns it, and then the flatten is because we have two paths to have none. The bound could be none, or we could get nil from this. Can you do a self-evaluate expression bound question mark? Well, this one wants to have an expression. Won't a question mark return early? If the bound is none, I want limit to be none. So bound value is optional value, and limit is an optional. So there's two ways you can have a no limit. You could have no bound, or you can have a bound which is nil, right? Either way, I want the limit to be none. So if bound is none, limit is none because we bypass the map completely, right? Yes. We would get a none, transpose does nothing, flatten does nothing, right? Well, transpose turns a none into an okay none, technically, right? Turns a none into an okay none. And then the question mark strips the okay off. And then the flatten turns a none into a none, right? If the bound is something and we evaluate it and we get none out, we get an okay none. So no, we get we get an okay none, yes. But then it's some okay none, which so we then you turn that into an okay none none, or okay none, which then flattens it to none. Yeah, this is just, there are like three different pathways that this represents. You could have an error, you could have some nothing, or you could have nothing. So the flatten turns the some nothing and the nothing into a nothing. The transpose and early exit handles the error. So maybe if I just wrote a comment that explained that, it would make sense to me. So that's the old comment. Let me write some new comments. Three possibilities. One, we have no bound. We have a bound, but it's erroneous. Actually, there's four possibilities then. And let's number them. I keep jumping page up rather than hitting period. It's annoying. 3, we have a bound and it's none, which is nil or nil. We have a bound and it's some, not nil. Okay. the transpose brings out any error and early returns it. The flatten collapses cases 1 and 3. So early return none, sum none, sum. Flatten collapses 1 and 3 together to none. And reduces 4 from sum to sum. So yeah, bound question mark was wrong, yeah. Okay. Till I find a better way to express it, I'm gonna just have a huge ass comment about it. Okay, and then here, 3 possibilities. We have no... let's just turn this into value. Then there are 3 different names. There's bound, value, and limit. We have no value. None. 2, we have a value and it can't be converted. But it fails to be coerced to use size. Early return. Let's make this shorter. But cannot be coerced. There we go. Fit. I made it fit. 3. We have a value that can be coerced to use size, and that makes a sum. An okay sum. Sum okay? And again, the transpose brings out any error and early returns it. So the okay or the error comes out, gets stripped off, so we're reduced to num and son. Okay, then I don't need this junk. I just have a huge ass comment until someone better at Rust than I am can say, hey, well, you don't need the transpose flatten. There's another fancy way to do that. Otherwise, it's not so bad, right? Because the essential things here are evaluate and try from, and these early returns if we have an error. And I've broken it into separate steps now. If there's a clever way to combine these and have one error return, that would be sweet, but I don't need it, right? This isn't an early return, well, this isn't a transformation really, it's just a check. That if there is some limit, we need to do some extra checks. So I could probably build that into here somewhere by doing like internally to that, but and then chain the error, but like why bother? Well, let's just keep it like this, right? Hey there, Adam. How are you doing? Wonder if a chat AI can tell you about a way to simplify that given your comment or given the code. I'd probably have to give ChatGPT a lot of context about what I'm doing. Yeah, I could try that. I could give ChatGPT this code with I could just tell it that it starts as an optional something, and then I'm going to call this function, and that function can return a result option, and I'm using it with map. So I could actually I could just give it the code and tell it the prototypes these functions and say, is there an easier way to express this in Rust? And maybe it would figure it out. It's worth a shot, right? Your thought is that there's a flat map, but you know if it really helps. Flat map was like to map and then flatten, but the problem is I had to do this transpose to get the result out first, right? Yeah, I think I'm going to leave it in the state of it's as good as I can make it, and chat didn't have a better idea. So because of this weirdness, I'm going to have a comment that kind of documents the flow and what happens. And then that's why we need to flatten. We have the early return because I just need to remember that if we have something fallible inside of a map, then we're going to get an error inside that we need to bring out and then return early. And that happens in two places, right? There's a map and there's something fallible. So we need to transpose to get it out and then early return it. Okay. So yeah, I think his name was Exceptional Ryan earlier today, told me about this next test in I have been used to running cargo test to run my tests, but it has a disadvantage that it doesn't give me a nice summary line. This next test is a plugin for cargo that does a bunch of cool things. And one of the things is it gives me a nice summary. So I'm switched over to use that. All right, moving on, right? I was just doing a whole refactoring step, right? So making a bitstream subset, it's as clean as I can make it now. Let's move on. Yeah, this I think we should have a different expression function for each kind of expression, and reference deserves its own function, especially because it reaches such insane depths of indentation, right? So should make a program that counts how many tests you have and print something like 124 out of 124 passed without running them. You know, it was really coincidental is the Lexer has 112 tests, and the parser had exactly the same number of tests, like 120 or 119. I think it was both of them had 119 for a while. No, it must have been 112. Yeah, they both had 112, and when I ran the parser unit test, I'm like, what the heck? Did I just run the wrong test? Because I got the same number just as I did just now for the other library. And that threw me, that was like a total coincidence. But now since then, we have different numbers of tests, and so that it's not such a funny joke. But yeah, 125 out of 124, exactly. I wonder what skipped means. I guess you could, on the command line, you could give a filter, say don't run the tests that have the word not yet passing in them, and then we say, yeah, we pass them all. Don't worry about the skipped tests. Some companies will do that, right? You need to ship it. You need to ship it right now. We have failing tests. Just skip them. Yeah, look, we pass all these tests. Ignore the number skipped. There's 0 failures. Yeah, extra credit. Okay, yeah, I want to break this out, but should it go in this file called context? Or should I make another level for expression? There's nothing bad about nesting this further, right? So I could make a submodule called expression under context and just put all these expression functions in it, right? Let's do that. So another level called context, and in there have expression. And then context has a module all to itself called expression. Okay. And then let's just go ahead and take this badass dereference thing out as is. Go into expression, and we're going to have like implementation for ingestion function evaluate. Well, it's well, it is evaluate, right? Evaluate reference self, and we're going to be given a reference is a reference, right? Reference. it's shared, and oh, this was part of context actually, not ingestion. It's supposed to give us, I think it was a result of some kind. It's going to give us a data value actually. It's an R value reference. I'm going to also need to have an L value reference now that I think about it. Data value. Ingestion error, which is a terrible name right now, but I'll fix that later. Paste. Okay, let's just get this to compile. Data value, import, context import from super. Don't mind the blank lines, ingestion error. There we go. Okay, I guess I called it R. So it's really called reference. And then error comes from log. Looks like I got the type wrong. Option data value, right. It could be nothing. You could get an okay, but no value out of it. And that's what nil is. Okay, cool. So this compiles. We have the warning because we're not using it. We need to make it public so it's usable. And go up to ingestion and go to where that statement was. Not statement, not ingestion. Context. Context. Here. And then it's going to be self.evaluate reference R. I think that's all I need. Now, that is sweet, and it should not fail anything because we're awesome. Ignore is a flag you can use for a long-running expensive test. You can even give a reason for doing ignore. I use it for a hacky dev config set of tests. So like if we had, what's our longest running test? Can we have it sorted by the longest? There's probably a way to do that, right? Help. Wow, there's a lot of help. There sure is a lot of help. Less, and then I'll search for, I don't know, time. How about speed? How about sort? Give me a break. I thought this was a cool thing. I thought it had cool features like sorting by how fast things were. I don't even, okay, there's, no, that's not what I was looking for. Where is it? It's probably in there. I'm just too impatient to find it. I can just buy I just want to pick something like, I mean, they're all super fast, right? It's too bad they're all super fast. I can't pick on any one of them. Okay, well, let's just pick one at random. How about we pick that last one because it appears last. Too bad I can't actually click and jump there. While there it is. So you're saying that I can, in this test, I can mark it as ignore? Like this? And then it'll not run it? Why is it taking so long to run? Oh, it skipped all of them. Skipped 16 of them. So I guess it interferes with test case. So it ignored all of the, it's even scrolled off the top so much. Can I do a less? Well, how come less doesn't capture it? Does it, okay, it does something, it prints the standard error or something like that? What a naughty tool. We have to do this to teach it a lesson. There we go. Where's the ignores or skip? Oh, it just doesn't even print a line at all. Okay, anyway, so you're saying I can give a reason? I can say like, equals don't tell anyone this test fails but we gotta ship it. And will it print that now if I run this? Have ChatGPT tell you how to sort based on the help text. Have ChatGPT replace this completely. Watch what you say, Adam. You might get what you asked for. Just saying. Okay, where are we going to see that lovely message? How do we see this reason? It looks like it's not printing the reason. I guess we'd have to like look up the manual like some chump to find out how we get that. All right. Anyway, that's interesting. So now now I know how to skip a test if I really want to. I just mark it with ignore. Fair enough. The streamers. No, it's not me. It's my boy ChatGPT. Threatens all of us. To, like you said, replace us completely. Either task worked on projects where a full test would take anywhere from 15 to 30 minutes. That's what kind of test though? If it's a unit test taking 15 to 30 minutes, then I feel both kinship to you and sorry for you because I have also worked on projects where the unit tests take 15 to 30 minutes and it sucks. That's poorly designed unit tests. Unit tests should be so fast. Ideally, you want the unit test to run every time you hit save. And the moment you break something, and the moment that you unbreak it, it should tell you, right? 15 to 30 minutes for an integration test, not so bad. But for unit test, that sucks. So we would have the subset of tests we would put on a dev test group, and then during our rapid build test cycles, you run only the ones we thought you were more likely to break. So that's one step towards fixing the problem. You would identify which tests actually are running in an appropriate amount of time, which would be 0.005 seconds or less, and say those are our good unit tests. And then the ones that are really slow, you'd say these are the unit tests we give to the intern to fix, right? That's how we use interns, right? Hey there, Krasner. I know Adam's here. Isn't it cool? Actually, Adam's coming back. Did you guys not know this? If you didn't, then where are you? But shout out to Adam Learns Live. He's going to return to Twitch, and no one will watch me ever again because they'll all be watching Adam, I'm sure. Can't wait for Adam to come back. So we'll just shout him out right now. If we shout him out enough, maybe he'll come back a little early or something. That's not true. I know you're not going to raid me, but just people won't watch me at all. They'll just go straight to your stream, right? Yeah, Adam's coming back soon. Can't wait. Okay, let's close everything and get reoriented. So I was in the ingestion library. I was in the context expression stuff, right? And I have the reference expression in here, but it's got something ugly in there I want to work on. I think we outended that enough so that, no, that's still a problem, right? It's not a bad problem. It's just that it goes on its own line, but I don't have to split it anymore. So I don't like this. I think I want to fix this. Also, this is really weird, the thing I did here with the trifold. And someone in chat pointed out that really trifold is not much more than a while loop. Maybe that's what I do. I just do a loop. I just get the enumerator, and then I just loop. And if I get an error, I do an early return. Like leverage those question marks, right? I'm already doing it way down here anyway, which by the point here, there's no point. Or by the time you get here, there's really no point, right? I might as well have done a map to do that and called it a day, right? Yeah, I could have just done literally dot map. What we get out of this is this thing, right? Well, this. I could have just done that and said this, and done, right? And then we don't even need these names. It's the same thing. So I think this is an anti-pattern, or this is a clumsy usage of trifold. It's not really doing anything other than making our life difficult with an indentation. So let me go to something more readable. That would be let ref chain equal that, and for the moment we'll do that. This needs to be mutable. Okay, so that's good. That's basically saying we're taking the thing that the reference is masking, or it's a new type for something else, which is really a vector of reference parts. And it's getting that and it's iterating that vector and then enumerating because we want to use the index for something special, which is to put a dot if it's not the first. Okay, and then I think what I want to do is I just want to do a for loop. For, and then I move these, right? And no, not right, these. I move these over to here. And I say in ref chain. Right? And then I don't need this weird trifoldness, really. It's just the equivalent of like saying let mute parent equal this. And then let mute path equal string new. And dump all this junk. Now we can outdent this whole thing, right? So this has to feed back into a couple things, right? Yeah, so that's part equal, and drop the map, and path we just update in place. So, which we do, so we're cool with that, all right? And then when we're done with the loop, I don't need to map anything. We just say part.value.clone. Easy, right? And we're gonna early return, so we need to wrap that in okay, because we made it. Okay, so then part, that's really parent, right? Well, let's not use the word parent. Let's call this part. That's really what it should be. And this thing with the error here, there's where we do our early return. Apparently that doesn't need to be mutable, right? Because of this. So actually, we can even be cooler and not even use a name. We can just say that goes there, and there we go. So we start at the composite level with no path, and then we're enumerating our references, our reference parts. I might as well just give this a full name, ref part. A reference to a part, right? And then n is like path step or something, or step. So if we're past the first step, then we add a dot to the path. Otherwise, we're adding the ID from the reference part, the reference to the path, and then we're looking at the part's children and looking for the next part, and it had better be okay, or else we're going to log a diagnostic and declare an ingestion error. Question mark will do the early return. So is that the best way to do that? Or would it be better to do a let? Otherwise, return. Maybe a let would be nicer here, right? So we do a let okay part equal that, else return. Even though the question mark is a cool operator, we don't really need it there, right? Can do that. That should be sum. And we have to put error there, unfortunately. And a semicolon there. Oh, we didn't use part? Oh, I have to say part equals that, right? Oh, wait. I can't do that. This is in an inner scope, or scope. So I need it to feedback. I need a feedback. So it's going to look weird, isn't it? It would be like if let some next part equal that, then maybe this is maybe this makes it easier to read. Part equal next part. Actually, we'll just call it next. If some next, or some child actually, and then we don't need that anymore. So that's more traditional, I think, easier to read, right? If some child is when we look up the key children by that ID, then the part is moving down to that child. Otherwise, there's an error, and then we loop back and we say, okay, now from that part, look up the next level, and we're building the path as we go. Okay, I think that's better. So it was a mistake of me to try to do that with fold and trifold and all that junk, right? I wonder if the movie's done. It's very quiet in the next room. And yeah, I think the movie's done because he's on his phone now. Okay. So if I clean this up enough, I think so. We still have some things to do when we have vector context support and we have other starting points, but yeah. Too much fun with method chaining. I know. We get the method chaining hangover. You add tap to your dependencies? What is tap? Okay. So expression's good, and then context was okay. So when we have other kinds of expressions that are more than one-liners, we'll put them in that expression.rs along with evaluate reference. Populate composite arguments. It looks kind of gnarly, but I think it's okay. Wait, I just thought of something. We're returning a result, right? I can make that better. I could just say let entry equal add in context question mark, right? Hey, look at that. Look at that slick use of that question mark operator. When you were least expecting me to be able to do that, I did it. Makes it easy to modify values of the method chaining instead of arguments. A library to get suffix position pipeline behavior. Hey there, kitty. Cat tried to sneak behind me. Look at this kitty. Look at this kitty. Tried to sneak behind me and do nefarious things behind my desk. That's right. Trying to like get to my cables and like eat them and like go behind the green screen and do naughty things. Now I just show the kitty the door. I'm catching on to her sly tactics. Yeah, I need to remember that when we're in a function that returns a result, the question mark operator is the shit, right? It's the go-to operator. It makes it very concise. I don't need to do this alternate, even though the let, this new let something, let pattern equals something else is really cool and trendy. That's more concise and I like it. I know, wasn't that such a cute kitty? Don't worry, she'll be back. Okay, this is looking nice. I think I move on to implementing something new. All of these to-dos are my choices of what I can do next, right? But before I do that, let's send it out of the virtual machine so that it's backed up in case I really blow up something. And then do one more passive ingestion.rs. I'm looking for like things that need to be broken down. Actually, we're really good. We're only at 162 lines. This is looking nice. Okay. So let's pick from the list of to-dos. Okay, what do we have? Ignore statements, conditionals. Conditionals are be kind of fun because we have all the pieces to do it. We have expression evaluation and we have the statements, the context, and then it gives us a chance to play around with binary operators that because we can say like if something equals something or not. I say we do conditionals next, but is there something else that I could do? Vector, construction, unary operators, sets, maps, functions. Functions are also kind of interesting. They're like parts with no bit streams. So that's another candidate is function. That might be fun. Binary operation. We'll probably end up doing that if we do conditionals. Break. Break. We need to have. We need to extend. We need to have something return out of execute statement because we need to break. We need to break out of this loop from here. That's actually not a whole lot of work. Maybe I should do that next. Because that's quick. I like to do the quick ones and save the hard ones for later. There's also local variables, but then I was realizing it's really useless without assignment. So yeah. Okay, I think I'm gonna do break next. So let's make a break test first. Test-driven development, right? The right way to do things. So do I just make another file? I think I do. Break. I can't call it break though, right? Because if I do mod break under test.rs, it's gonna throw a fit because break is a reserved word, right? So what should I call it? Like break statement? Because I have to? I think that's what we have to do. Break. Actually, is there a diagnostic there that tells us if we can name it break? How do we do it? Oh, we can. We can put an R hashtag in front. Why don't we do that? Because we're cool like that, right? Now you can tell everyone that you know a really esoteric bit of Rust that you can actually name something after a reserved word if you put an R hash in front of it. Okay, so break. I've been rather fond of taking the references test and copying it, and I think that's fine. We only need one test though, so I'll delete the first test. And this is going to be a test break. I just realized something. We can't test break without a loop. It doesn't actually have any meaning outside of that. I'll construct the test, but we will always be failing it. So, aha, ignore it. Now that I know we can do that. Yeah, we have to have some kind of loop. So, what's the best kind of loop? I guess just a loop that does one iteration. So, while 1 break. Actually, let's actually have it do some parsing. And then what we can do is I can just observe the side effect. Have it read a bit have it read 1 bit. I mean, we'll just observe the side effect on the bitstream, actually. That's the best way. That's the easiest way. So by the foo format, we'll go into an infinite loop, read a bit, and then break. And what that should do is should stop the parsing. Actually, what it should do is it should continue on. So what if we do another UI1 out here? That will parse 2 total bits. So if we have a 0, actually it doesn't even matter what I put here. When we ingest, I don't care about the data. So drop it. In fact, what's better, let underscore or drop? Drop, I kind of feel like it's like telling it that we don't care about the return value. We only care about the side effects. With the bitstream handle, I can still ask it its offset, right? Yeah. So I'm going to assert that the offset is going to be 2. If we go to bits and we ask it for its offset. To do that, I got to do borrow, though. Offset. There we go. So if I were to run this explicitly, it will fail because we have it unimplemented for the while loop. And I'd rather not do the while loop now. I'd rather do conditional. So we can do conditional, and then I'll promise to come back and do while, and then we'll be able to test the break statement when we have the while statement. Conditional. So we'll do the right thing, and we'll predict that we will need a self-execute conditional statement. Its fields all are alternatives and otherwise. Alternatives, otherwise. And I'm guessing that we're going to need self because it's going to recursively call execute statements again. So yeah. So let's go add that near part statement, right? Collapse that guy. And him, and just add them to the end here. Actually, should try to keep them in order, so conditional would go first, right? Pub function there. And I guess while we're at it, let's just oops. I thought I lost it there. Let's put execute error statement here. Part and then return, right? We can collapse these because we're not looking at them. Okay, alternatives. Let's see if I can guess what it is. It's a vector of I think I just called it conditional. And otherwise is a vector of statement. So that's a spanned statement. And then context is mutable context. Let's see if I got that right. So what is the type of it? Go back until we find it. Conditional span, that's what I got it first try, right? Statement. Yeah, conditional span statement. Conditional span statement. All right, cool. Import it. All the things. All right, and then go back here and make sure I got it right. Okay, so if they're vectors, do I just say as slice for both of them, I guess? No method found. Did I not mark it as public? I did. It's an ingestion, so it's self. Okay, what am I missing? Oh, did I forget to put self in there? I did. Mute self, right? There we go. So did I maybe I didn't need the S slices at all. I did not. Sweet. Okay. So the gist of execute conditional statement is we go through all of the alternatives. Each alternative has an expression to evaluate, and if it evaluates to anything that's not zero-ish, then we execute the statements in a smaller context. The context of just these statements, or actually no, the context is the same, right? But it's a recursive call in to execute statements. So, and if none of these expressions evaluate to zero-ish, to one-ish, they're all zero-ish, then we go and then we execute the otherwise statements. So it would be for alternative in alternatives. That gives me a borrowed conditional. We say if I kind of feel like I should have an early escape hatch. Did I do that on some of these other ones? I didn't on any of them. Shouldn't I though? Because like if we try to evaluate an expression and it bombs, well, let's see how this goes. If context evaluate expression alternative dot condition borrowed I think we want to do a match here. Okay, if it's an let's do the error condition first. If it's an error, then the context, well, actually, doesn't this already mark, if it doesn't already mark the composite as bad? It doesn't. Okay, it leaves it up to us, so we have to do it. Context.component composite.error equals true. And I think we just return early, right? But if it is something, and I don't care about the error actually, I'm wondering though, what does this print if there's something bad? It'll just say something's not found. I think that's okay. Okay, so if it is some value, then I need to actually make sure that the value can be evaluated as a truth. So I'd rather, because we have this other places, I'd rather have this maybe do only the while one. I think this conditional is easier than the while. Because with the while I have to, well, maybe they're about the same. I don't know. It just seemed like the if would be easier. So if it's a value, we need to basically test it for truth. So can I do a bool try from value and then match that? Actually, what would be better is, no, for this one, I do want to have an, its own match, because if that's an error, we actually do need a diagnostic. So this will be, it couldn't be convertible, right? Error. Oh, we have a log error. So context. So not context is itself. On error. No. Context on error, right? Yes. That's confusing to me. But I'll get back to that. The message here would be, why is it capital message? Oh, because it's an asref string. Right. I forgot about that. What do I want to say here? That in this particular statement, I know what statement we're on. So what if I track choice or which? And then I can say format. And we're going to end up doing this too up here. And the idea of the format is I can say something like this. I can say expression. Well, how do we want to phrase this? Like ifs and else ifs are like conditional logic. So condition did not, could not be evaluated, or what? Could not determine truth from, it's not truth, it's truth or falsehood. It's could not determine I don't know how to word things. I suck with words. I'm always slow to word these things. That's okay though. Not everyone can be perfect, right? I want to do a comma there because I want to say which plus 1. Because humans count from 1, computers count from 0. Could not determine, not truth, but like, how about could not determine if condition in alternative blank was true. There we go. Number. Do I have to double the number? I think I do, because pound by itself means something else, right? Actually, we'll see. I can't remember, like, on its own, it doesn't need to be. I think by the color, it's saying that it has to be doubled or something like that. Could not resolve? Thing is, if it couldn't resolve it, it ends up here. It couldn't evaluate it, right? Here it could evaluate it as some value, but that value couldn't be cast to Boolean for some reason. Or resolve to, thing is, resolve to what? Resolve to Boolean? That's like, that's, for a programmer that makes sense, but to a user that wouldn't really make sense. I'm just gonna leave it like that, I think, for now. Oh, this is to be enumerate. Iterate and then enumerate. Okay, so I need to have a from data value for bool implementation before I go much further. So let's do that. So I have a try from for usize. Now we need a try from for bool. Errors, ingestion error, because why not? Make a uniform error type. Here we go. Oh, we're already printing something. Okay, if we're already planning to print something, then I don't need this at all, right? I can actually that makes this a lot simpler. If I don't need to do that. Oh well, hold on. It's still useful to know which alternative because we might have a whole bunch of else if, and this would identify which one. So I'm gonna leave that one there. Go back and I think we're gonna follow the same kind of recipe. Only this is gonna be easy. This is gonna be okay. U is not equal to 0. And the same thing for the integer. If it's not equal to 0. What about floating point number, though? We could say it's not exactly 0.0. It's sort of stretching it, though. Right? Not exactly 0.0. Okay, what about a string? Maybe that one we say it's not coercible. Or it could be like, if it's empty, it's false. If it's not empty, it's true. Or we actually look for words like true and false. And we might want to standardize their case. So yeah, what if we do match s dot to lowercase, or can we do as? To lowercase, I guess. Or is there like a case comparison? A case insensitive comparison? I think there is, right? I can do like a case equal ignore ASCII case. But I have to do that on a case-by-case basis. I was wanting to do it in a match. We'll just do this. So then we would have like, if it's empty, it would be false. Or false. Or no. Or off. Alternatives. True. Yes. On. This really should be bool. A result bool. Actually, I can just make this a bool and make all of these if there is an error, we can do an early return on them. That would be easier, right? What's the deal here? I have to dereference them. Okay, cool. Oh, right. I did want to put them inside of OKs for that reason. That I don't want to do an early return. If I want to for an error on the way out, I want to print something. Okay, so let's have a catch-all case. Then it's going to be an error. Ingestion error. Unable to coerce that value, and then we're done, right? What's wrong? Oh, because I said bool up here. Okay, fix that. Now we're good. Done unpacking and washing the Vegas stank off. I don't even want to ask where you got the vaguest stank. Do you just pick it up by just being there? Oh, you mean like the cigarette smoke and the alcohol splashes and other things that might have landed on your clothing? Bingo, exactly. I see. Okay, I'm sad that that didn't work. The trait bool convert from option. Oh, it's an option. Yeah, so if it's none, I think it's false. So let's just say if it's okay sum, okay none. Yeah, so we're doing nothing if it's false, right? Because we just want to keep looping. If it's an okay true, though, then we want to break. Okay. Then I think we don't want to break here, right? This is a continue. So it's that. So we need to tell the difference between breaking and then running out of alternatives. So I think the way we'll do that is we will do what here? Actually execute the statements in here and then return. Sounds good to me. So to execute the statements, it would be self dot execute statements alternative statements in context. It's scary, but I think that's what we do, right? Yes. Okay. If we get down to here, we actually I guess we only need to do this if it is empty, we're going to return immediately. So it's always safe, right? If we get down to here, we're doing execute statements on the otherwise. Self.execute statements otherwise. That's actually not too bad looking. I don't like the indentation level of that, but I'm not sure how to make it better. It's everywhere there, huh? Smoke is the worst. It gets in clothes, hair everywhere, nasty stuff. So has the amount of smoking in Vegas gone down in the last, say, 10, 20 years? Anybody who's remembers going there 10, 20 years ago, has it gotten better or is it just still as bad? You have to see the sphere. I've heard that they make it look like a big eye and it looks really cool. Okay, is this ready to test? Unfortunately, I didn't actually think to make a test first. Yes, this, if it's that, we error out and then we do that anyway. I need to make a test. I was lazy and didn't make one. So let's make one. Conditional. Tests. Mod conditional. Okay, let's actually steal from the one we haven't tested yet, which was break. And save here. So this is, we'll test an if. If one, return 42. Return 69. We don't need any bytes. I guess I could turn my light back on because the movie's over. There we go. Now it doesn't feel like I'm being interrogated anymore. So when we ingest foo, we should get oh, well, I don't need to type this. I can copy it from somewhere else, right? Like integer. Like one of these. Go back. So we should get unsigned integer because I didn't put a sign on it. 42, right? So let's not ignore that test. Let's make sure that this actually works. No, because I have a compiler error. Oh yeah, let data equal that. Okay, try again. Got 69. Okay, we failed. Oh, I know why. I remember that having this problem back in the C++ days too. Problem is the return only breaks out of one level right now. It'll break out of this level. It won't break out of this whole level. It's got to basically return short circuits all the way out of the current format. You had a shot of the sphere. Copy link. Go to browser. Open tab. Paste link key. That's cool. I like it. It's sort of. I like it when the whole thing looks like a big eyeball. That's pretty impressive that they made something like a huge spherical projection thing, right? Creepy. Well, that's everything in Vegas is to grab your attention. So it grabbed your attention for sure, right? Okay, yeah. So this means that there's a problem with the return statement, right? Either that or it did something with that, but it fell through, or it didn't go into the if. Actually, we need to distinguish between all these possibilities, right? So if we go into the if, let's parse a bit. Okay. And then let's have an else. To make sure it doesn't do the alternatives, we'll parse 2 bits. And if we get out of here, I'm going to parse 3 more bits. So if we go into the if and we return, it'll be 1 bit. If we go into the if and we actually don't return, we'll have 4 bits. If we go into the else only, it'll be 2. And if we go else and then fall out, it'll be 5. So that way I can check exactly what it is. So was it break? Yeah, this by the bit streams offset, we will know. Right here. So it should be 1. I have to actually put a dummy byte there. Let's see what we get. So we get 4. What does 4 mean? That means it fell through and did the 3 there. That's the only possibility it can be. Think your wife has some pics of it as an eye? I'm sure I can find them with the image search. Although let me do this off stream, because I might be getting myself into trouble by doing this. Sure, Google search. Vegas sphere eyeball. Yeah, image search. Yeah, this one. This one's cool. Copy link. Why am I being redirected? I don't know, but here you go. Oh, I hate ads. That's pretty dang awesome, I think. You go there and you just see this huge eyeball looking at you. Yeah, image searches should always be done off stream, right? All right. Okay, so we need to fix the return thing. And the way I did it in C++ is we would actually have a return scope enum that we would propagate all the way back up. And if the return scope was return, it wouldn't stop until it got out of the part that it was in. So let's look to see how this is done. Close everything. Ingestion source. Remember to hydrate. All right, ingestion statement. Here we are. Execute return statement. So it doesn't break out at all. It just sets a value. Okay, that's bad. I didn't have a test for that to ensure that it actually returns, but I should have done that. So let's do that. I have a special return statement, don't I? Did I not test it? I don't have a test for return statements. I never made it. Okay, disappointed. We'll make sure we'll break no, conditional is testing return, right? Okay. I have been schooled. I do not have a test for return. We were leveraging it, not knowing that it actually didn't behave correctly. Okay, well, we need to fix it. So, statement. Okay, there's... If error is true, it's an automatic return all the way out, right? But if it's not true... well, return is always going to go back up, right? So maybe where return is called. Find all references. Here. Yeah, so maybe this should return some kind of like... There was that control flow constant, right? Can I leverage that? Continue or... No, it's close to what I want, but it's not exactly, right? That's like Rust-like anyway. Let's not do that. So like, in C++, I call it return scope. So maybe I should just continue to call it that, return scope. So I should be able to find references to that if I search. Yeah. So I had next, break, return, and error. Proceed to the next statement in the same group, next statement in the parent group, next statement in the parent. Oh, that's a copy paste problem. Look at that. I copied that to, oh wait, no, it says part instead of group. Next statement in the parent part. Yeah, that actually is true. It's unfortunate that all the text matched up to the last word. Error should stop completely due to error. Okay. I think I just want to copy this whole enum from C++ and port it to Rust. So it would go at this level, would it not? Or would it be under ingestion? I think it would go under ingestion. So here under ingestion, we're going to make a new module called return scope.rs. Paste that stuff in. Go to ingestion. Do a mod return scope. Use return scope. Okay, and then we remove the word class. Turn these into 21st century comments. Actually, I wonder if there's a shortcut in VS Code to do this. Toggle block comment. That almost worked. Because then I can then just say all of these are slashes, and then I can just remove the excess ones, right? I can actually do a select all cut, and then I can even do a triple slash select all cut line, and then we're done. Okay, and then remove that. That wasn't so bad. Make this a public enum. Go back up to here. Okay, and then we should be able to use return scope. Okay, so a part statement needs to return a return scope. Okay, that should be imported. Okay. This would be return scope error, right? Return to me. Return scope next. Okay, and then back to here. Conditional needs to return to return scope. Import. Can I not import that? Why wouldn't I be able to import that? Oh, it's already there. It's not an error because of that. It's error because of this other returns, right? Actually, the execute statements should produce a return scope, right? It already does. No, it doesn't, but it will. It will go back. Okay, so if it's false, then we are continuing. Okay, if we break out, that gives us the value we want. If we're returning here, it's an error. And same thing down there, actually, right? Cool. This should be a return with a semicolon. This does not return, it just goes to the next, and so does that. What was the difference between that and that again? If we evaluate the expression and it's nil, it goes to there. If we evaluate the expression and it's not nil, but it matches to false, then it goes there. Okay, fine. All right, back to here. So yeah, here's where we got to do like a match on this, right? So a next does nothing. A break does a break, which really just ends up doing a return scope next, right? Actually, it does a return scope next. We want it to return immediately. A return is not only do we return immediately, but the scope is return. How many times can I say return in one sentence? Maybe 3 or 4, and then I start to go crazy. Okay, an error is it's also return immediately. And if we break out here, actually, why don't I just put that out here and then turn a break into a break. And if I wanted to be cheeky about it, I can say continue. So a next just goes and does the next statement. A break breaks out of the statements, but we go to the next thing in the outer scope. A return goes all the way back out of the part. An error also goes all the way back and stops completely. Okay, that's good. Moving on. Return statement always. Well, hold on. That should have a different scope. So let's just take off the semicolon and have it translate that for me to return scope return or error. Okay, back. Error statement. We know what that does. That always returns an error. That always sets the error flag, right? So it's always going to be return scope error. All right. Is that it? I think that is it. Yeah. I think I'm missing something though, aren't I? Hold on. It passed everything, so it must work, right? We skipped one thing and we don't need to skip it anymore. That was break, right? We don't need to skip this anymore. Okay, we failed the break test. Panicked and not yet implemented for while. Oh, right, because we said we needed the while loop. Break. Yeah. Okay, well, with the exception of the break test, everything passed, right? So then I never actually did anything with return versus error. So how did that actually work? That's the only place we use it. How could this have possibly worked? Find call hierarchy for that. So this ignores the return scope. Oh, because I don't have a test for that. We need to have a test where we actually generate an error and it should fall all the way out without executing the next statement of the outer. Okay, so I have an error test for that. Maybe we can do it there. Yeah, so the way we would do it is I would have a spam or something, or like just a, actually we just return a value, 42. This should not, oh, not in this test, because this is an erroneous test. I should do it in the test that it will actually work here, right? Without a value, with the value? Yeah. Just do a bar, don't return. Why did I have a return bar and a bar? I don't know. So this should not cause it to return 42. So in here, I should make sure the data value is none, right? And I bet this test will fail now. Yep, it's going to fail because it's going to say it's 42. Right, so to fix that, we actually need to use the return value of execute statements in both places, right? Custom and then conditional just percolates it up, right? So does this one. And so does that one. And that's backed up at the execute statement. So it's just this one right here. This doesn't, and this one doesn't either. Okay, so then this one needs to return a return scope. And then we take off the semicolon there, and then both of these, it's an error, right? Return scope error. Good morning, 0 down 1. Okay, then where that's called. Okay, here it is, right? There's a loop at some point. I think it's right. Yeah, we need to propagate the return scope here. And that's return scope error. And here, all of these need to return the return scope. Okay, so then I have to hit all of these. Let's do the ingest ones first. Is this not accessible? We can make it. We can make it accessible. If I elevate this up one level, which I'm going to do right now, plop. So here we're going to have a mod return scope. And then this, we got to fix it because that's not where it comes from anymore. We don't have that module. And then we will import it from the crate. Statement can now import it from the crate as well. Like so. Okay, back to component. Now we can put it. Whoop! I didn't mean to do that. Okay, so all of these need to return a return scope. Although now that I think about it, like they're all going to do the same thing. It's very predictable, right? Is that the error flag was set? Yeah, but it's just cleaner this way. Okay, so let's just hit all the early returns. Everywhere, right? That's going to return scope error. And then the fallout one is return scope next. Not so bad. Okay, and then back, wait. Back to here. Ingest is common, right? Return scope. Further back one. Okay, I don't know where it goes. So let's do that again. Show call hierarchy. Ingest component. Okay. Here's where it gets tricky, right? Because this was just doing a map here, but we could have a return scope. So how do we deal with that? Ingest in context returns a return scope. Let return scope equal that. So what do we do with that? If we're going to return a data component, I have to put that somewhere, right? And this is called by who? By execute parse statement and ingest component. They're going to have the same problem, right? This is just forwarding, so it's going to have the same problem as the caller. This one does have a return scope, so I can maybe get this to work here if I determine how to get it out of that. Maybe one thing that leaps to mind is we can combine the scope with the data component in a tuple. What if I just do that? Data component and the return scope. What would the data component be? It's going to either be return or error, right? No, I guess it could be a next. No, it can't be a return. It's going to either be a next or an error because a return statement would have just broken out of our loop, right? Actually, I guess it does go all the way back up. Yeah, okay, so it could be a return. No, we don't want it to be. Hold on. When we're doing this loop, where is it? This one. Okay, yeah, we have to be careful here. I have to map the return value of this. Because this is a part, right? Yes. So I need to match the return value of that. So error goes to error, but everything else goes to next, right? Everything else goes to next. Because we hit next if the last statement was not a return. Break, I don't think doesn't even mean anything as a statement if it's not in a loop. So I don't think we'll ever get that. And then return as a last statement just assigns a value and it'll be the same as next. Yeah, so these are all the same. These should return next. So I should just make these all alternatives like that. If it's next, break, or return next. So then the other way to say this is to say if it's an error, return, otherwise it's next. So then it's just if return, if error equals that, then it's an error, otherwise it's a next. Like that, right? If let. Yeah, okay. Then what, I broke something here? Oh, right, because I said we're going to return a tuple. So that's that and return scope. So that has to propagate back up through ingest itself, right? Oh no, this is the top level. I don't care about the return scope here. I just want .0 from that. That's weak, so what if I do it this way? Like data, and then I don't care what that is. Returns, we can actually put return scope here if we want. Put a underscore in front of it saying we're not going to actually use it, and then just say data. Then when I read it later, I'd be like, I hate saying .0. So if I see this later, it actually gives a name to it, and I'll be happy. All right, and then this is called from other places, right? Yeah, so here we have errors now because we're not doing the right thing with it. Unwrap or else. Yeah, so it's data component return scope, right? Error. And then this is really a part and a return scope. And then that's just propagating the error flag, and then it's just return scope at the end, right? I think that's it. So now let's try the tests. Okay, and then bring back. Oh, that was it, right? That included the test I modified to check for this. I think the break test. No, it was not that. It was a return test, right? So where was that again? Statement? I can't remember. I'm already lost. I don't know where it was. It's in a break. It wasn't here. Conditional? Yeah, it was here. Okay. If this test is working, then we're good, right? Yeah. So the return returned out of this completely, and we only parsed 1 bit. Right. Okay, good. Then in order to test break, we need a loop, right? So let's do the loop next. But now that we've done the other things, the loop shouldn't be too bad. I feel that I should also have another test for the else if before I move on, actually. What if I do that? This shouldn't take too long. So just an alternative test. Say test else if. So it would be like if 0, else if 1, and then we'll just do another prime number here. So we'll do 5. So now it should be 5 bits. And let's have this be 16 or something like that. Run that test. Cool, that works. Hey there, try catch TV. You won't see very many try catches in my stream because this is Rust. And in Rust, we do results. We don't do try catch. So you see a lot of OKs and errors rather than actually catching things. There are no throws. There are only just return OK and error and that kind of thing. I don't know if you rated me before. Let me tell you what the project I'm working on is. Yeah, so I'm resurrecting an old tool and converting it to Rust. It's called the DataDisintegrator. It's kind of like Wireshark, if you've seen that, right? Where you drop a whole bunch of packets in raw bytes and it kind of figures out what it all means. And you can click on things and it shows you what where the bytes are for that. So we're pulling apart the bytes of some file or stream. We're figuring out what the meaning of each piece is based off of a format that's written in a special language. So the tool includes a compiler, compiles a program into an AST, and then does an in-order traversal of that along with some binary data. So an example I like to show, if I can remember the key combination of this. Here's a GIF file, right? It starts with GIF 89A. If we put that side by side with a format description of GIF, right? GIF file starts with the header and ends with a trailer. And what the heck is this? I have a loop and I have conditionals. Is this a structure or is it a function? It's both. When you run the tool, it will say, okay, walk this data structure through with this file and build up an understanding of what each byte means. So start with GIF, with header, which is the first part of a GIF. The header has a signature, which is a string taking 24 bits. So it takes these first 3 characters, interprets it as a string, checks to make sure that it's GIF, otherwise flags an error. Then as a string called version, parse another 24 bits. That's these 3 bytes, 89A, great. Then we're done. The version is the overall value of the header. Then we go back up. The next one is logical screen. So we go down into that. There's a descriptor. We go into that. There's an LEUI 16 for width and height. That's just little endian unsigned integer 32 or 16 bits. Then we have 2 built-ins unsigned integer. One's called LSB, other one's MSB. They're 8 bits long. So we take these next 2 bytes, the 2C and the 1, which is 44 decimal and 1. Shift the MSB up 8 bits, add the LSB, so you get 300. And you can see the next 2 bytes are also 300, right? So that's the width and the height of the GIF image. So if we run through the entire file with that, it gets all the way to the trailer and match. So the entire file matches the format successfully. And then with the output stuff we collected, we can get all sorts of information like there are 61 images in this GIF. It's 300 by 300. And if you're wondering what the lol GIF looks like, it looks like that. So I'm porting this to Rust, and I'm working on the 3rd stage of it right now. So I already did the lexer, I did the parser. Now we're doing ingestion. So we're doing it in order traversal, and the AST looks like this. So at the top level, kind of like what's implied here, and I can show you in the grammar also, there's a concept of formats. So the top level would be a format, has a name, has some arguments, and has some statements, right? And then a statement can be a part. So a part would be like header, or it could be a loop, like a for loop or a while loop. It could be a conditional, if else, all that stuff. It could be a return statement, and so on. So these things like can nest. So like inside of a for loop, you can have more statements, and inside of those, you can have more for loop with more statements. It visualize it as a tree-like data structure that we're just following in order. It's an instruction file, yes. Jittering ASTs across language is next level. Well, I learned from this book. It's called the Dragon Book because it's got a dragon on it. Compilers, Principles, Techniques, and Tools. It's an old book because I'm an old programmer. There's a second edition out now, but that book is really nice because it walks you through the fundamentals of making a compiler the old-fashioned way, which is lexer, parser. A lexer is just a bunch of regular expressions that turns your program into a sequence of tokens. So my lexer looks like this on its output. So it says that that is an identifier, and then it recognizes that that's a left brace, and then another identifier, semicolon, another identifier, semicolon, and then local is a reserved word, so it just says local. So is while. All these numbers, it's remembering the line numbers and column numbers where each of these tokens starts and ends, so that if we hit a syntax error, it will tell us, well, there's a syntax error on line 7, column 16, or whatever. So that's the first stage of a compiler, lexer. The second stage is called the parser, and that generally uses a bunch of grammatical rules to describe how those tokens would fit together to make a meaningful program. So for me, the top level is formats, and it's basically saying we're going to build a big dictionary where the keys are strings and the values are those formats that I talked about before. And we build that by either having nothing, or from another formats, which starts out as nothing, we have a next format where we're just taking that map that we started out as empty and we're inserting something into it. And this is recursive because it's self-recursing, right? The parser generator matches these rules by doing two operations over and over again until it's out of tokens. Shift and reduce. Shift is where it takes in a new symbol and it adds it to the list. And then when the entire list matches one of these rules, it does a reduction. So it takes the whole list that it has so far and reduces it to one thing. And in the reduction, it runs the code that matches the rule. So that's why when it had a formats and it has now a new format, it reduces it to a new formats by doing a map insert, right? So something else, like in the middle, you might have a statement, which is like a for loop, right? Has a for, left parentheses, your loop variable equals some expression, semicolon, and then some condition of how long the loop should go, and then another statement for the incrementing the loop variable, left brace, some statements, right brace. When all of that gets matched, it reduces to a single statement, which is a for statement, which has all the things we collected. So, and then at the very, very bottom, you have all of the literals. So, as a very innermost expression, you can have an integer or a floating point number or a string, and those just get encoded as literal expressions, right? Punctuation always appears as things that are in rules, but that don't actually get used. So there's no like name in front of it. They're purely to help disambiguate the language. So I used a crate called Lollipop to make this. This Lollipop stands for look ahead, left, right, and then the pop I think is just to make it make the name fun. But it's like a mixture of Bacchus-Norform grammar and Rust code. So Bacchus-Norform is where you have a grammar rule, and then you have a list of ways that that grammar rule can be matched. So rule, colon, and then some list, and then matches, and then another list matches something else. That's Bacchus-Norform. But then in the body of each match is the actual Rust code that the parser would execute whenever it reduces that rule. Is it possible to generate an AST for an entire code base with multiple languages? Yes, you'd have to mix the languages together into the same token set and grammar, though. What you do is you'd have different grammatical rules that mix at some level. So you might have a C Pascal rule, which says that you can have like either C or you can have Pascal. And they would, I'm not going to write the whole rule, but if you imagine that you have one symbol that's either C or Pascal, so it's either C or it's Pascal, you put all the grammar rules for C under C, and you put all the grammar rules for Pascal, go up to Pascal, and then this is a unifying rule that says you can have either one. What I'm doing is pretty close to a byte, what do you call that? A bytecode engine, a runtime engine, intermediate language. Yeah, pretty much. Only what my code does is it doesn't generate code. It generates a report of saying what the file contains. Very similar to what Wireshark does. When it gives you this report on the screen, it interpreted a byte sequence, and you're seeing its interpretation as kind of like the combination of the input with the program that it compiled, an interpreted byte string. Hopefully that makes sense. All right. So yeah, thank you for the raid, Try Catch TV. Today I'm working on, let's see, whatever my today command says. I'm going through the code wherever it says to do, and I'm filling in the code that I'm missing. So you mean parsing multiple languages in unified AST? Yeah, well, you'd have to unify them at some point. So you'd either mix the rules, or you'd have two different rule sets that have a unifying rule at the top. That's how you'd mix them. If you mix them not at the top, it might get a little messy because the two languages might have different ways of expressing the same thing, and then you have problems with the grammar rules being ambiguous. That's the bane of the compiler developer's existence, is language or grammar rule ambiguity. That's where the parser generator says, I don't know how to make your compiler because you have a token sequence that could mean two different things, and I don't know which one to pick. And there are ways to deal with grammar ambiguities, and the Dragon Book goes through it. But and one like brute force way is you just say the first rule that matches, follow that. And then you might get into like a tricky situation where when you mix two languages together into a unified AST, you might have written what you thought was C code, but the compiler said, well, my Pascal rules came first, so I'm going to interpret that as Pascal. And it does something slightly different that you didn't expect. One place where you see unified ASTs are in things like, here, let me show you an example. It would be the U framework. Let's show you an example code. Can we see an example? Get started. Concepts. Let's look at one like components. Yeah, see this? It kind of looks like Rust, but it also kind of looks like HTML, right? You have a tag in there. When we get to more exotic examples, yeah, see this? Doesn't this look like a unified AST where you have HTML mixed with Rust? It's because it is a unified AST, and the way it works is you have a Rust macro that handles everything inside the macro is using a different compiler. It's using it's not a full compiler. It's a compiler-ish thing that's made with Rust macros, but it is in the pure sense of the word, this is a unified AST because the outer nodes are Rust and the inner nodes are HTML or HTML-like. So there you go. There's an example of a unified AST. Whenever you see like a language embedded in another language in the same source file, you're seeing an example of that. All right, so I had just finished implementing the conditional, right? And I had not done the while loop yet. I was going to do that next. So I have a test for break, which depends on the while loop. So if I, this is as good as time as any, take out the ignore and run my tests, and this will fail, right? Should run and fail this test. There we go. We failed the break test. And if I look, it'll say exactly where it failed because it's not yet implemented the while loop. So it's time to implement the while loop. So I'm going to take the dot off. I'm going to fill in the structure fields, and I'm going to do the same thing I did for a conditional. Paste it, and I'm going to say execute while statement. I'm going to give it the condition and the statements along with our current context. Okay, so then I'm going to want that near where I have conditional. So we can collapse that. So let's sort it alphabetically. So this would go last, right? Execute while statement. It's a public function. It has, I think we do need self for the first argument. Okay, I need to get the types. It should return a return scope like all the rest. And we can just mark it to do at first. And we need to get the types of these things. So context is that. And I'm not cheating, I swear. Statements, that should be like scoped or yeah. Spanned. It's getting late and my brain is not working as well as it was when I started almost 4 hours ago. Span statement list, right? A condition is a expression. So if I got that correct, then where we call it will work. Keep going back. There we go. So no error here. So that means that this is good. So now if I ran my test again, we can do it just because we're pedantic people, right? It'll hit a different oh, I have a typo. That happens because my keyboard is got a little bouncy. Let's go there. Yeah, bouncy keyboard did that. Okay, go back to break and run the test again. Yeah, so we failed the test because it's not implemented at this to do now. So that's where our work is. This is called being a lazy programmer. So you just keep trying to run the test until it passes, and when it fails, you just look at the next place you need to implement. Been trying to do this in reverse, analyzing the languages in IntelliJ codebase and then trying to create a common grammar for it. Yeah, I guess that is going about it in reverse. So you could either do that where you study a language and come up with a grammar, or you can start writing the grammar for what you kind of want to represent, and at the end you'll have a new language. Yep. One cool thing though is that this has been done hundreds and hundreds of times, and you can find this all on the web these days. So it's not too hard to like do a Google search and find like Java grammar, right? And then even if you're not trying to do Java, if you're doing C, C and Java have a lot of similarities. So if you wanted to get like work on grammar rules for a language that's like C, you could actually go to Java, get the grammar rules, and then like tweak them to be closer to what you want. All right, we need to do the while statement. So fundamentally, we're going to have a loop, right? Because we have to execute the statements over and over again while this condition is true. So we're going to say if context.evaluate expression condition actually, I guess what we're going to do is going to do a match, right? Because it could be an error, in which case we're going to do kind of the similar thing as the conditional. What did that do? I did this because we had multiple alternatives, but I don't think I actually need to do that anymore. Actually, I didn't for the outer expression. I just did that. So I'm just going to steal that. Because why not? Stealing from myself is fine, right? So we don't care about the actual error because evaluate expression as a side effect does diagnostics internally. So if the expression was bad, we would get something that says like why it's bad, and it would tell us where. And so that's enough information, right? So we don't have to pile on and say that, oh well, that expression was for a while loop, and so we have an error in a while loop. No, we don't have to say that because this will have already printed that enough. So to okay, that's going to be value. And so similarly to the conditional, I need to do this junk. Oh, actually, it could be some value or none, right? So now that I think about it, there's a lot in common between a conditional and a while loop. Only difference is the outer one is enumerating alternatives, and then we print which alternative it is. So this is going to be similar but not quite the same, right? So it'll be some value, and then we coerce it to a Boolean. If we can, then we execute its statements, and it's not going to be alternative statements. It's just going to be statements, right? And if it's false, actually, if it's false, we want to break. We're breaking out of the loop, right? Actually, I guess we can just return immediately. It would be return scope next. Right? And then if it's an error, I actually don't care about this because the try from actually also has the diagnostic. Okay, so what if it's none? Then it's also should return to go to the next thing after the if, right? Or out of the loop. And this whole thing is basically saying it. What is it saying? This never actually loops. Oh, right, because if it is true, we don't want to return. We want to execute the statements, and we need to look at the return scope, right? We need to match the return scope. That tells us what we're doing. Fill match arms. So if it's either of these, right? If it's break, then we're returning next. This like this, right? Yes, I think so. If it's next, we're doing nothing. And that's where we'll loop back, right? And if it's a return, Actually, I guess the return returns and the error errors, right? Yeah. So if I save this, then it should be happy. There we go. These should all be returned, right? Yeah, okay, good. Hey there, TS Just. Good morning. This looks funky, but I think it's correct, right? So let me run through it. A while statement does a loop. And every time we loop, we evaluate the condition expression. If it was okay and had a value, we try to convert it to a Boolean, true or false. If we were successful and it's true, then we're going into the loop. We execute the loop statements, and the return scope says what's the conclusion of executing the statements. If it was next, that means we got to the last statement and we're done. So we actually want to loop back up and evaluate the condition again. But if we got a break in the loop, we want to break out of our loop, but go to the next statement past the loop. If we got a return inside the loop, we actually want to propagate that up and return out of the part that we were in. If we got an error, we also propagate the error up. Okay, if we evaluated the expression and it was false, then we don't go into the loop, we go to the next statement after the loop. If we evaluated the expression, no, if we tried to convert it to a bool and we couldn't at all, it's an error. If we tried to evaluate the expression and it was nil, then it's like it was false. So it's the same as this condition. We go to the next statement after the loop. If it is an error to evaluate the expression, we bail. Makes sense? So kind of hidden in there is the fact that we have this. Maybe it would be easier if we said continue. Because then it's explicit that, oh, we're going to go continue the loop, right? Okay, let's test it. Break has a loop in it. And it failed. Something's not implemented yet. Oh, never implemented break. Okay, well, that's easy. Don't we just turn that into a return scope break? I think so. Let's test it. Run it again. Hey, it passed. I like passing. Do you like passing all your tests? I like passing all my tests. I have a 295 of them now. How long should I stream for, chat? Should I go until tomorrow's Sunday? I can sleep in. I can go all night. It's only 4 hours. I might want to take a break to like get a soda or something. You guys wouldn't mind if I took a break to get a soda at some point, I hope. Maybe I'll show you the cat. All-nighter. You mean all dayer for you, right, TS Just? It's morning for you, so you want me to go all of your day. I'm already feeling tired, and it's like not even 11 o'clock at night here. So what are you up to, TS Just? What are you and Tim doing these days? When is Turbo Boom gonna be released? Huh? It's on my wish list. It's been on my wish list for years. I want to play Turbo Boom. I'm wondering if I should make more tests around breaking and looping. We should have something that doesn't enter the loop. That's what we should have. And this deserves its own test file called a while. And we're also going to abuse the Rust reserved words by putting an R in front in order to do that. And why don't we just steal from conditional and copy? Actually, you know what? Strike that. Let's take the break test and copy it to while. Paste. And we'll call this like while true. No. We already have a while true test with a break in it. How would we do a while false? So this would be like something that's false. So here, we should only see 1 bit, not 2. Parsed. Here we go. Tim doesn't want his next game to be a time trial game or something like that. So now he's playing with his homemade physics engine and setting up multiplayer and other game template things. But does that mean that Turbo Boom is on hold? Or does that mean Turbo Boom is going to like morph into some other kind of game? So he doesn't want his next game to be that, but is it the next game? And so he wants like an intermediate game? Okay, so what are the other possibilities? We could have something in there that's garbage, right? So like a while arg. So what that should do is be an error. So there should be 0 bits, and we'll enable the logger so we can see it. So this is a while bad expression, bad condition. Here. Unable to coerce value arg to usize ingestion error. Actually, this is the wrong diagnostic. It should say bool. I'm glad I tested that. So that was in data value. Yeah, this should say to bool. Go back. Try again. To bool. Yeah, Turbo Boom is on hold and will be released after the next release. Arg. Yeah, so here, this is an example of a program that compiles, but at runtime, we basically don't know what to do with that, right? What is that true? Is that false? So I do have some flexibility, so we can have a while true string or while false string. So you can say, I think I have, you can say false, you can say no, or you can say off. So let's do a false. So that should give us 1 bit, right? There we go. In fact, I could use test case to catch all the false cases, right? So we have a test case where we have false. And here I want to do a literal false. So R pound this, that. The format was this, right? False string. And then we have to put in like condition static string, and then I have to actually bake it in here. So like this, condition. Is that not how you do test case stuff? I'm already losing track of how you do that stuff. Test case. So what am I doing wrong in my test case? Where did I use test case? I don't know. Let's search for it. Oh, we have to do use test case. That's probably what I'm missing. At the top, right? Yeah, there we go. Okay, cool. So isn't that the syntax? Didn't I follow that? What's wrong with that? Unexpected token. Why is it unexpected? It should be as many parameters as I have, right? Does it need to be on its own line? Does it have to be not a reserved word? No. A comma? Do I have to have like some other word there? No, that's not it. It doesn't like that. Oh, it has to be a string. Like that. Okay. Like that. Oh, and I need to have a name? Wait, what? Thought I did everything it wanted. Value, comma, value, semicolon, that inside of that. Isn't that what I did here? What's wrong? Expected 0 arguments found 1. Well, I have a variable there. Found 1 argument. Why is expect 0 arguments? Unexpected argument of type static string function defined. Oh, I have 2 things called while false. Yeah. So that's another case of this where it's 0, right? So 0. So we're combining test cases. Okay. So we have bad condition, and then we have the 0 conditions. And then, okay, I guess I can't do this with raw string. You might have meant to use string interpolation. It only works in format invocations. Oh, right. Format. The diagnostics from Rust are really helpful. What's wrong? Oh, that it thinks that that's an interpolation, and that too. And that too, right? And that too. Okay, cool. So then that has to be borrowed. And this whole thing, it says it's useless. Why is it useless? Consider doing, well, but, oh, that is an interpolation. That's intentionally an interpolation. There we go. Okay, run them. Run them, run them, run them. They all passed. Right, so now I can combine and show all the different ways we can do false, right? So I believe it was false, and it was no, and it was off, and it was empty string, and 0, and I think I even did like 0.0. You can have negative 0 or positive 0. Negative 0. I can go on and on. This is float 0. Okay, so let's make sure all of those translate to false. Okay, I have a problem. String is redefined. Oh yeah, that's empty string. This is off string, no string, false string. All right, all the negatives. And then we should probably have a positives test too. Okay, let's do the positives test. So this is a while true. True string. Yes string. On. Not that. Non-zero. Float non-zero. So 0.1 or something like that. I don't know. Positive 1. Positive non-zero. Negative non-zero. So let's do positive 69, negative 420. They should all be considered true. So that's where there's a break on there so we don't get into an infinite loop. So we should get a 2 there for all the true tests. Okay, so we have some bugs. Oh no, we have a collision on UI. Okay, that's important. That means the test is not valid. That's right, we have UI defined in 2 places, so we need to actually give them names. How about inner and outer? And I need to do the same thing here to be fair, right? Yeah. Arg. Okay. Run them all. Wait, why is there still a collision on inner? There shouldn't be. That break didn't break, that's why. And also, it is going to collide until I have vector context. So that break should have broken out of the loop, but it didn't. Okay, so I need to see how do we evaluate break when we're in the wake state while loop thing. Let's see. Statement. Execute while statement. So if we get a break, we should return. So did we not get a break from the statements? Oh, wait, that's a problem. A break should return break, not next. Yeah, that's the bug. Glad I caught that. Back to while loop tests. Run them. All of this should be fine. Nice. Okay. Run all the tests. 311 now. Okay, good. So yeah, this, if it did more than one loop, it would be a problem because it would try to redefine inner because I don't have the concept of vector context yet. So in other words, like this has the name of foo.inner, right? And so it'll parse a bit as foo.inner, and then it'll loop back and it'll try to parse it again next bit as foo.inner, and it's going to collide. What the vector context means is when you enter a loop, it does an implicit index, right? So inner becomes a vector, and now n is incremented every loop, and so it's no collision because inner 0 and inner 1, inner 2 are all different slots. And if I had like a bar in here, then it would be like foo.bar n, and if bar was another format that had like another like UI, I don't know, Baz, then that would be foo. Well, when it parses the bar here, it's going to end up being there's a bar and there's also a bar.baz, and this is not in vector context because this is not in a loop. Only bar is. So it's going to be one foo, bar is going to be a vector, and then every slot of bar will have a baz in it. Hopefully that makes sense. Since I didn't do vector context yet, we have to make sure we break even if we get into the loop, otherwise we're going to have a collision. I think one feature that would make my language stand out would be running the loop a random number of times in error cases. No other language does this. I'm not sure I know what you mean by error cases. Do you mean like making a fuzzer? Like what's an error case? What do you mean by error cases? Most languages have either built into them or through a library standard to the language a function called random or something like that, where you can either collect real random numbers from real sensors like the keyboard, timer, or mouse or something like that, or just pseudo random numbers based off of a seed. And you could use the value returned from random to control how many loops you do. If I'm interpreting you literally, then I think most languages can do that. But maybe you probably meant something different that isn't possible in most languages. The language I'm making, remember, it has to do with parsing data, so it wouldn't really make sense to do a random number of loops because then it won't match the data unless the data is fortunate enough to also have a random number of constructs inside of it. Does that make sense? So again, like My language is geared towards parsing real data. So like this loop, for example, it breaks out as soon as it sees the trailer byte. If it didn't, then it would say end of data unexpected. Or if it broke out sooner, it would misinterpret a data block as a trailer. So either way, it wouldn't work. So I guess I just don't understand what you mean by error cases. Unless, are you talking about like the test cases here? Because yeah, I'm basically assembling a different program here based off of the use case. And sure, we could use a random number and that makes me think of a fuzzer. A fuzzer is a kind of test tool where instead of using predetermined test inputs, it just uses random numbers, and it doesn't actually do asserts most of the time. It's just trying to make the program crash. And so a fuzzer will be coupled with a crash detector, and it basically runs forever with different random inputs until it finds a crash, and then it tells the developer, hey, with this particular random input, I got a crash with this stack trace. And then that's one way that you improve the security of your code. Was a now outdated joke around wrong types and conditions? Oh, I'm sorry, I didn't get the joke then. While loops, that's an error because there's no implicit conversion to bool, and run the loop 3 to 4 times. Oh, you mean like for the arg? If it's arg, then it's like, well, rather than not parsing anything. In fact, we should also assert that there's an error. Let me do that. That was here, right? Assert data error. Go back. So let data equal ingest. So we want to assert that the error flag was set because of that, right? So you're saying like instead of calling that an error, we just randomly choose true or false? So you either get 1 bit or you get 2 bits out of foo, depending on how we feel like interpreting R. Is it yes or no? Okay. That would be one way to mess with someone is instead of flagging that as an error, a compiler error, you say, okay, fine, your program's good, and then at runtime you just do something completely unpredictable. And then like they're like, why is this program so unpredictable? And then they finally step through it with the debugger, and they're like, oh crap, that should give me a syntax error. Oh, it didn't. What does it do? Oh, it just tells me something random each time I call it. Then it's like, okay, there's someone joking around with me. All right. So we're done with conditionals. We're done with while loops. Let's look for to-dos again. Down to 14 of them. For loops are pretty much like while loops, only they actually have a local loop variable and an assignment. And that makes me think I'd rather do the locals first and do for loops later. Bounds is interesting. What that does is it does an inner scope with a tighter limit. And it will also skip the bits that you don't use and give you a warning about it. So maybe we should do that next. That'll be a fun one. I think I want to get a drink first, so let me go do that. I'll be right back. Until then, enjoy the chair stream. Oh, look at that chair. That's one cool chair there. Okay, we're doing a bounds statement. We're going to do a unit test first. Close all the other files. Bounds it is. We're going to copy from break. That didn't do what I expected. Copy from break. And go over there and paste. Test bounds. We need to make sure we can import this module. Okay. So a bounds would be something like this. I think we just put an expression here, right? X. It's like an alternate way of parsing something. Y. And here we'll say 5 to try to blow the bounds out, right? Okay, and then let's make that 2, and then we'll have like 2 bits left over that will not use all of them. So we'll be able to see the warning, right? So here, unsigned integer is designed to like use all the rest of the bits if you don't say a bound. If you do give a bound, it'll try to use more. Here it'll try to use less. So I expect this will parse, this will get an error, and this will parse but will have a unused the rest of the bits problem, right? Actually, that we should reverse these. Otherwise, the error will stop us parsing, right? Or is the whole point that we should be able to get an error? I think the whole point should be we get an error, but the error is captured by the bounds and we continue. I think that's what we should do. So that way we would expect with some bits, let's do 0, 0, 0, 1, 1, 0, 0, 1. So we should get that for the first. So basically break it, we should be getting those things in the bounds. And we should get an error for the middle one. And this one should only give us a 0 out. And we should get a warning about an unused bit. Okay, so then ingest, so we're not dropping, let data equal that. We will parse exactly 8 bits. Even though we didn't ask for 8 bits and we asked for more than 8 bits there. Okay, so then we want to assert certain things, right? That overall there should be an error in data. What's this problem? Not in groups of equal size. Okay, fine. There. Happy now? So assert data dot it's not helping me do this. Is that because of something I did here wrong? Maybe I do that. Here we go. It's better now. Keyed children dot get x unwrap. Let's call that x. Let's make sure we actually have an x, y, and a z defined for children of foo. In fact, why don't we call that foo? Because that's what it is. Then we should assert that not x dot error. X shouldn't have an error, and Z should not have an error, but Y should. Okay, and then since there's no error for X, we can assert that it has a value of 1. So that's sum data value unsigned integer 1. Okay, and then also Z should have a value of 0. And we will, we can actually also ask for their offsets. So X dot origin dot unwrap. Well, let's do asref unwrap offset should be equal to 0. I think we should be able to, even though there's an error, we should actually know that the offset of Y is 4. And that the offset of Z is 6. Okay. And we can also get the limit. Limit. So that limit should be set by the bound, right? Is that true? No, that the limit, it'll be a boundary of the context. The limit will be 1. So that'll be 1. The limit of Y will be, it's erroneous, right? So we don't even gonna care about that. It blew its bounds. But the one for X is 4. Okay, so X has a value of 1 and it's offset 0, limit 4. Y is erroneous, it starts at 4. Actually, it'll have a limit. What do we expect it to be? Let's say that if it's an erroneous limit, that we set it to whatever bits remain. Or no, let's make it 0. So it'll have consumed no bits. I think that's appropriate. If that's erroneous, it should escape the bound, not consuming any bits, and then skip all of them, right? Okay, so this is going to fail with not implemented because we haven't implemented bounds yet. Here we are. At the bounds, exactly where we expected it to be. So we're going to remove the dot dot so that we can do so we have a bound and a statement. So here we go. Execute bounds statement, giving a bound and statements. All right, so just like the while loop, or any of these other ones. Yeah, let's copy at least part of this, and up to alphabetically it goes here. To do. If I hit the right key, it'll actually do a exclamation point and not a Z. Okay, so bounds. So this was bound, right? And that's an expression, and we have statements. Okay, so this should fail the test bounds at the to-do that I just added right there. Cool. All right, so then the way I think that this should work is it should make a new context, executing the statements in that new context, and that new context will have a boundary set according to this bound. So it'll be very similar to how a part works. So I could look at how that is done and execute part statement right here. Yes, so somewhere here, I guess it was build? Yeah, we do this thing, right? And we make a bitstream subset based off of that bound. And that's fallible because it does all this junk. Right. Okay, so this is essentially what I want. It will make a bound. It will make an origin, basically. And that becomes... Actually, I don't need the whole origin. I really only need this limit. Oh, and I need to do this check too. So I basically need to do everything that make bitstream subset did, but I don't need the bitstream subset. I just want the limit out of it. So what if I make a copy of this whole function that basically just determines the new limit? In fact, we're going to call it determine bound limit. Determine limit from bound. Determine limit. Calculate limit. Make limit. I don't know what to call it. Determine limit. Okay, fine. So I don't need an origin, do I? I need it for the inner bound. So I guess we do want to borrow it. Yeah, okay. So then the option is not a bitstream subset, it's going to be a limit, which is a usize. And it's going to do all the things that the other function did, except for just at the very end, we're just going to say it's some limit. Like that. Then what I should be able to do is use, is that not the right type? Oh, it's just okay limit. Yeah, then I should be able to just use this function from the other function. So it should be just all of this. Self.determine limit origin bound, and then I would do a question mark, or I guess I would just do a map, right? Map limit to it really has to be this, doesn't it? And it's only if it's okay. Okay, then I have a way to do that. I can say determine limit question mark, then map it to okay some of that. No. Expected result option, found option result. Oh, yeah. It should be transmute, transpose. Getting close. Oh, do I have to flatten it? The inner limit's a usize. And then oh, do I need to put the okay on the outside? That's why. that dot map to that to that. No, almost. Missing some punctuation. Too much punctuation. Okay, how close am I now? We have two levels of options somehow. That becomes an and then, right? Or just remove the sum. Yeah. Okay, that's what we do. Okay, there we go. Oh, nope. Oh, does this take an option? It does. So then I don't need to do a map, right? I just do that there. Call it a day. Okay, I thought that would work. Maybe because of this comma? No, it insists on putting the comma there. Expected option bitstream found. Okay, this actually does need to be an option. Why? Why? Okay, let me undo this. Let's go back to what I had before. Okay, that whole thing is replaced by this, right? Not exactly. This had an okay limit around it. Okay, so then I don't need, okay. Then yeah, I was on the right, I was off on the wrong track. That gives me an okay limit. So there's already an okay around it. So it would be a map limit to just sum there. I did it. So we determine the limit based off of the origin of the bound, and we map that limit to some bitstream that has some bitstream subset of the original bitstream to that limit, and that limit itself is optional. So there are three possibilities. It's either an error, it's there is no bitstream subset, or there's a bitstream subset with no limit. That's right. Okay. Now that I've split that out, I can reuse this determine limit in the other place that I wanted, right? Where was it? Here. Yes, so I wanted to like parse. I wanted to get the limit from the bound. So let limit equal self dot determine, is it context dot? Determine limit. I need to make it public, I guess. Okay. It is there. Wait, how come I can't use it from here? Does that have to be public to use it? Oh no, it's in context. So it does need to be public. Okay, now I should be able to use it. Context dot determine limit. There we go. Okay, so the origin is the bitstream subset. So that's context dot composite.origin as ref, I think. And then bound is an optional expression. So that'll be sum bound. Okay, what does it want? It wants it wants a reference to a bitstream. I think the problem is this is optional. So yeah, we have to throw an error if you get to a bound statement and you don't have an origin. And I printed something special for that in the C code. Let's see what I did. Decomposition, decomposer. There should be a place where we do a bound statement bound around here somewhere. Let's just search bound. There it is. Okay. It cannot set bounds without a bitstream. That's what I would do. Exactly. And then it doesn't allow a negative bound. So this is the function I was just working on does that for me. Yeah, and then I make a new context and I execute the statements within that context. And then if we didn't use all the bits, then we fast forward to the end and we translate our return scope. Yeah. Why didn't I just say return there? I don't know. Okay, so so this is the one special thing we need. So back here, you would say let some origin equal context, yeah, that thing down there. Composite origin as ref, else context dot on error, the message cannot set bounds without bitstream. And then context dot composite dot error is true. Return scope error. Okay. We get down to the end. It should be return scope next. Okay, and then here we would just use origin. Cool. So now we have a result. So that could fail. And if it does, so yeah, I need to check that. So how did I do that back in ingestion for a part? Oh, I bundled it in a result. And if that fell out, I did unwrap or else. Okay, that's what I did. So I don't need to make a data component. So it's actually much simpler. I just do return scope error. Okay. So again, it would be let OK limit equal that else. Do I need to set that or does determine limit do it? It doesn't have a context, so it can't. All right. But this will print the requisite things if it fails, right? Yeah, it'll print stuff like that. It'll print that, exactly. Okay, cool. Oh, wait. We don't have context for that error. We should have it though. This shouldn't do error directly. It should do self.onError. And then we should put that message in there. So that should be a format, right? Format. And then do that. And then do a double like that. And borrow, right? No, I shouldn't have to do a borrow. What's wrong with that? Cannot borrow self as mutable. It's design. Okay, this has to be mutable. Oh, yeah. Mutable. There we go. Which means that this has to be mutable. Which means that this has to, oh, this is okay. Uh-oh. We can't do that because origin is borrowed. Oh, that's a problem. We were talking about this earlier about making that callback, that error, it was about the error callback that we can use interior mutability. But yeah, actually, now that I think about it, using that statement context shouldn't force me to make this mutable. So let me look at that. Why is this mutable self? Oh, because it sets that. Okay, what if it didn't? Because the problem is that in order for that to work, then this whole thing has to be mutable. Let's have it not return, let's have it not be mutable to just make it easier on myself, and then I won't set the error there. But then now I have to be careful. Everywhere where that's used, I have to be careful that the error is actually set. Yeah, so it's not set here, so we need to set it. Composite error equals true. Yep, here as well. Here we can't do it, but we're returning a result, so our caller should do it. So I'll get back to that in a minute. Wait, we're also returning an error here, so our caller should do it, right? Yeah. So I have to check those two. Execute bound statement. Yeah, I already was doing that there, so we're good. Okay. Yeah, we're already setting that there anyway. Here we're setting it, yes, and there we're setting it. Okay, so then places the second order stuff I have to check. So yeah, this determine limit, call hierarchy. Sets the error, good. Next one. This one does not, but it returns an error. And that returns an error. And that sets it. Okay. Oh, but it does an if part error. Okay, that's not good. Oh, but it gets the part by setting an error. Okay, good. All right, so we're good for with that one. Hold on. On error. Let me look at this again. I'm just making sure that all places set the flag. Right here. Populate. I need to check this one. I muted it just in time there. Okay, that's called by here, and oh, that doesn't set it, does it? Yeah, we have to set that there. Okay. Okay, I did it. I did it. I did it. Although I'm not really happy about having to do that everywhere. But I guess it makes sense. If uh if we're getting a result, then we're assuming that the error flag is not set because the error is being communicated differently. So we should assume that the error flag is set if there could have been an error and we're not actually returning a result. So it's actually consistent now. Okay, we're consistent, we're good, we're moving on. So one way to fail, another way to fail. This one will print a diagnostic for me, so I don't need to worry about it. Okay, so at this point we have an optional limit. I think then we require a limit, right? So it had better be something. So it would be let some limit equal limit, otherwise it's another kind of error. Hey there, tasty T-Dev. I speak like Bob Ross, but from the programming world, anti-stress stream. I try my best. You know, happy little mistakes happen when we're programming too. So you just have to take a deep breath, look at the functions around you, and touch up a little syntax here and there. Okay, I'm porting some code from C++ to Rust, and just a really quick taste of what I'm doing. I'm working on a tool that pulls apart bytes from a file and figures out what they mean based off of a description written in a domain-specific language. Here's a domain-specific language that describes, in this example, a GIF file, right? Starts with a header, ends in a trailer, has some data blocks in the middle that has pixel data, right? Logical screen has a descriptor where you'll find the width and height and other interesting information about a GIF file. So it's a lot like Wireshark, where the raw bytes coming in off your network are interpreted to mean different kinds of packets, and the packets have different protocol layers, and it'll break it down and show you what all the bytes mean. So I'm kind of I'm aiming at that. It's like a general purpose decoder. You're programming in JavaScript. So I'm programming in 2 different languages simultaneously in this stream. My tool is written in Rust, but the tool includes a compiler for a domain-specific language that has a sort of dual nature. Each of these is a format, and a format is both a structure, like it says that a GIF contains a component. It's composed of a component called a header and another component called a trailer and yet another component called a data. But it's also a function because when we go top down, it's giving instructions on how to assemble or disassemble a GIF. You would start with the header. You would then go to the logical screen. You would go through the data blocks and you'd have a trailer at the end. The tool is what I'm building. It's called the DataDisintegrator. Again, it's very similar to Wireshark, only I don't have a GUI yet. It's taking data in and it's like interpreting what it means. So here's an example GIF file, right? It begins with GIF89A. So the C++ version of the tool, I don't know why it did that. There it goes. Basically, it is following this as a recipe on how to interpret these bytes. So the fact that it starts with GIF, we interpret it as a string because we say it begins with a header, and the header has a string 24 bits long that's called signature. Then same thing for version number. Then we go into logical screen, which has a descriptor, and it has one of these, which is all the way at the bottom. It's 8-bit LSB, 8-bit MSB, assemble it so it's 300 pixels wide. Hope that makes sense. keyboard. We made that last year. So I 3D printed the case. This is a 36 key keyboard. The controller is a Raspberry Pi microcontroller. Had the PCB printed by a board house. Did all the soldering. I did not write all the code. I based it off of some embedded Rust libraries. The switches are Cherry MX brown. So the Cherry MX brown. So they're hot swappable. So I can pull them right off the keyboard and show them to you like that. Although if I do that too many times, it'll probably wear out. And as I'm pushing the keycap back in, it's printing the character. Disadvantages, but also advantages in having hot swappable keys. I'm finding out with hot swappable, if you swap them too much, you start to wear out the little pins on the switches, and then the socket probably is also getting worn, and that it's actually causing key bounces. So I either have to like replace the switch, or maybe I go into the firmware and adjust the debouncing algorithm to be more loose. But the advantage is I can change this to the clicky blue switches if I want, or when they wear out, it's easy to replace them. The advantage is the other way would be solder them in, then they're going to be a lot more robust and not break so quickly. Disadvantage, can't swap them out for something else, right? So I'm implementing different kinds of statements that my language supports. And in this particular one, it's kind of a weird one. So here's a specification. It's called a bounded region. It says within this region, there will be 4 bits. So X will be a 4-bit long unsigned integer. And then it says there will be a 2-bit region, and in there will be a 5-bit Y. So that's going to be an error. And we should get this very, very specific error saying that the inner bound exceeds the outer bound, right? And then here is another example of a bounded region of 2 bits, but we only use 1 bit for Z. So there it should parse, but then we should get a warning saying that we did not use all the bits, that there's 1 bit we didn't use. And we're asserting that the different things, X, Y, and Z, start at certain offsets and have certain limits and have certain values if they parse correctly. And now just making the code work. So this is literally parsing the bound and then the statements within the bound. Right, bound and statements within the bound. Bound comes in as an expression. Also we're also operating within the context of some composite. So in this case, it's foo. And foo will have a bit stream tied to it when we call the ingest function. Here's the bit stream. And we have to check, well, we have to have a bit stream, otherwise it's an error. And then given the bound, we're going to determine the limit, and that it might exceed it, right? Then there will be an error, or we get something back. And then the next level is it has to actually have a bound. Otherwise, it's pointless to have a bound statement. So I was going to go look and see, what did the C code do for this? I keep going back to this function, this file, so I should pin that. Okay, so if there is no bound, what do we do? So we evaluate, oh, right. We coerce to a value integer. I think we get a null pointer if it can't be coerced. So let me double check that. Coerce is a value type. Yeah. What's a static type? Static pointer cast? I don't remember that at all. Huh. Sometimes I just don't remember stuff. Like, I don't remember writing this. It was many years ago. But I do remember writing coerce. So we were going to coerce to value is a value, and we're going to coerce to static type. Oh, right. That's the marker of what the type is. And this is saying if it's the same type, then we don't need to do anything. But, right. So we're going to go to the original is Well, it's going to do nothing, right? It's just going to return the value. But what if it's nil? That's what I wanted to check. What if it's nil? So I want to go to value nil and see what, I guess that would be the base here. If we coerce it. Oh, right. So if you try to coerce it to anything else but nil, you get null back, which would cause this to error out. It would say unable to coerce it. Okay, so then I never really printed something. I just assumed that it had to be a number. So I guess what I want to then do, because this does the coercion, right? But it allows there to be no bound. The bound is optional. So yeah, I just want to say there's an error here then. Here we go. We're going to do it. Let's say bounds statement with no bound doesn't make sense. There we go. Okay, so now the limit is a usize, and then now it's easy because we're just going to form a new context and execute the statements in it, just like a part statement would do. So let's find where I do that here. And it's just ingest, it's inside ingest component we do this, right? Yeah, we do. Well, first we have to make the context. Where do I do that? New with part? Ah, right. I'm not going to bother adding to the path because I don't think the C code did that. Let's go and see. What did it do? It just made a new context, right? Bounds context. It didn't change the path at all. Yeah, but it did do the skipping extra bits part. We have to don't forget to do that one. You just got a Kinesis Advantage 360 with silent pinks. They're really nice. Is a silent pink? How is that compared to a cherry brown? The cherry browns I like because they're pretty silent, but there's that tactile feel. You understand you've done a declaration syntax parser to serialize data from bytes to string. Why do you need it? Is it part of something else or is it useful for specific tasks? Who would use this tool and why? I'm just doing it for fun, but also in previous projects, for example, if I'm making a game and my game has save game files and those save game files are in some kind of binary form, like they're just serialized data. Let's say we used serde, right? We use serde to write the in-memory representation of our game state. We wrote it to a file, right? And let's say like I want to look at my save game file without actually loading it into the game. I just want to take a look and see what's in it. I could describe the serialization of my game state in my in the tool's language and then open it up. And the idea is some GUI like this where you can just like poke around and look at things. So it's for fun, but also might have some practical applications for me if I want to like poke around at files that are hard to read otherwise. Doesn't have a built-in serialized deserialized class? Yeah, but then you'd have to write a Rust program to do it. What if someone just handed you a file and you wanted to take a look at what's inside the file and it was binary? So probably what you'd do is you'd have like a binary, a hex editor like this. You'd have a hex editor. But what if you wanted more than this? What if you wanted to like click on a byte and it would have it tell you not only is it this in octal or hex or 32 bits, well, what if it told you that's the third pixel on the second row and it's red? Wouldn't that be useful to you? Right? Or what if you could tell it that, hey, this should match the GIF format, and then it would verify, yes, this is a valid GIF file. Or it might say it's valid up to this byte, which is an error. Yeah, so exactly, a more comfortable hex editor, a more capable hex editor. One viewer pointed out that there's something called the 101 editor, and I misspelled it, but it found it anyway. So this is like a step up from a normal hex editor, where you can like script the UI or the engine in it so that it understands a little bit about the format and can do highlighting and junk like that. But Wireshark is like the ultimate because it has pluginable extension point, right? Pluginable dissectors that you can invent a whole new protocol, plug it into Wireshark, and it'll understand it. But I would say primary reason, just for fun. I've used tools like this in the past to learn formats that I found interesting, like MPEG transport stream or MP4 files, GIF files, right? If I want to get some like experience like doing LZW decompression, then there's not much further I need to go other than what I have so far in this file, right? The LZW blocks are in these data subblocks right here. Here's where, if we wanted to, we could assemble a second level bitstream to parse in a second pass the LZW encoded data. So it might be fun to try to describe LZW decoding using my language. You have to do it in a second level pass because these blocks are separated by these sizes. So what you do is you'd make a higher order bitstream, which is the assembly of all of these bounded regions, one after the other. Gator on brown stem low force. So the browns have 55 grams and the pinks have 35 grams. So that's like a little bit lighter then. And there's some noise for the browns, but very quiet for the. So it's basically a lighter touch, very, very quiet. That's cool. 010 is not nearly as capable as what I'm creating. It's just a step up from like, I can't tell you how many times like at like jobs and stuff, I'll run into like binary data. I'm like, I don't have the decoder for this. I just want to see if the file's good or not. I just like to run it through a comparator or a validation tool to tell me, hey, is this file broken? And if so, how is it broken? So I guess I've been burned too many times in the past not being able to have a tool to do that. So I'm motivated to make one. Okay, bound state with no bound doesn't make sense, but if it did, I wanted to copy from was it in my clipboard? No. I wanted to copy from the part statement. It's this context that it builds, right? Do I just want to make another constructor here? It would be a new or subset bound, right? Yeah, let's do that. Let's make another constructor. Yeah, so this would be a new bounds or new bounds. So we don't have a part. We just have outer context and then limit or boundary. Bound? I'll call it limit. Limit usize. So it's supposed to take the offset and use the offset and the offset plus limit to make a bound, right? So outer context. We're not going to do anything with that path, actually. Path is the outer context path. The boundary, this is where it's special, right? So we need, I guess we'll have this pre-computed anyway, right? We'll know the offset. This boundary is, oh, wait. Relative to the start of the bit stream. Okay, so actually that's, I don't need an offset. I just need a boundary. Boundary, there we go. And excellent option, I guess. Make it flexible, right? Composite is the same composite. Actually, am I going to run into trouble because this is not reference counted? Yes. In fact, I am. Okay, how am I going to deal with that? I could just hijack the context and then set the boundary back. So rather than making a new one, I can just hijack the current one. Why don't I do that? So I'd call ingest component with the context without making a new one. But I have to restore the bound afterwards. Okay, then that's what we're doing. There's no arguments. It's not a component. We're just doing ingest in context. Yeah, so we're just doing this. There's no arguments even. Where do those arguments go? Arguments. Oh, this is not even correct. Yeah, what? Go back to statement part. It's ingest component, right? Ingest in context. Oh, it was inside of here. Yes. It's execute statements. Yeah, okay. I just want to do execute statements with an adjusted context then. Okay. So back up here. We're going to remember the original bound is context.boundary. Oh, is it not public? Okay, we'll need to make another, actually then, why don't I have this be update boundary? And then we pass the new bound in it, the limit. I'm using these names interchangeably, which I don't like. Oh, wait, there's a problem. I actually want this number, not the limit. Well, okay, we can just do that there, right? Let boundary equal. Yeah, that actually works. Okay, so then it's boundary. And at the end, we need to set it back to the original. And then also we need to check, right? Let actually, I just need to do if. Context, no, if origin dot bitstream dot borrow dot get. Oh, just offset. If that's less than boundary, then we're doing that warning, right? Context on warning. And I'm just going to copy from here, skipping extra bits. So format, skipping some number of extra bits at the end of bounded region. So that's, I guess we should just sample that. Offset is less than boundary, then it's boundary minus offset bits that we're skipping. And then we do the skipping by doing the, again, origin. Try that again. Origin dot bitstream dot set, no, borrow mute. Set offset. Boundary. There we go. So, and then we update the boundary to the original boundary afterwards. And yeah, so between here, we want to execute the statements. So that's self.execute statements. And we get a return scope back out. So I have to match that. So here it's statements and context. Yeah, cool. And then we're going to need to match that. Okay. Fill the match arms. So next does nothing. Actually, I need to do this match afterwards. Hold on. Let return scope equal that. And then later we're going to do a match on it. Down here, actually. Actually, don't I just return the return scope here? I think it's just return scope. Yeah. Okay, so then we just need to have update boundary. No big deal. Let's put it near the end. Okay, public function update boundary, mutable self. Boundary is an optional usize. And it returns the old option usize. Let original boundary equals self dot boundary. Self dot boundary equals boundary. Original boundary. Done. So this should be sum. Uh-oh. Can't borrow it mutable because it's immutable. Where do we borrow it? Immutable borrow in line 22. The origin. Oh, crap. Okay. So I have to get the origin back again after. Yes. So it's this offset we need to get later, right? So then I need to repeat, well, I need to repeat some of this, but not all of it. So we do it here, right? Let origin equal this as ref expect. The origin was here before. Where did it go? So that's something where we don't expect is like does a panic, but it's because it shouldn't happen. But if it does, and we're debugging, we ever see that, that gives us a hint about like what expectation we had something that's irrefutable, but we can't say that at compile time in an easy way, because we have this and we return if it was none before. It shouldn't suddenly get one down here. Oops, did I delete something? Oh, I did. That's offset, right? Boundary is offset plus limit. Oh, wait. No, I did delete something by accident. Hold on, but I want this again. So put that back. Okay. And then we have to get it again like that. Yes. Well, we already... yeah, that's right. Okay, cool. Now what? Okay, so we have a borrow on line 40. Okay, well, we can use the origin first, and then we can do the warning second, and then we're fine with borrow checker. Okay, borrow checker is just being very strict on this. You can kind of see with the underlines that the this is an immutable borrow to get access to that, but and origin came from a right. It said origin came from a mutable reference to context. Take that back. Origin is borrowing the bitstream subset from something within context, right? So once we do that, as long as origin is in scope, then we can't borrow from context for anything else, unless it's also immutable. But context on warning requires a mutable context borrow. So we can't do this unless we give up the origin, and we can give it up because we're not using it after this line. But if I had that line after, the problem is we need to hold on to origin until this line. So we can't call anything mutable on context because origin is borrowed from context. But if I flip the order of those lines, it uses that origin and then it discards it so that it can go back to context mutably and do a warning message. Okay, all of that. It's taking me a long time now because I'm getting tired. So I should probably like call it and come back at this tomorrow. Let's see how far we got. We got a panic. No, yeah, we got a panic on our test. Our test didn't match. We did not get a Y child. Do we not insert it if it's an error? It should get inserted. Okay, I'm not printing out the log. We should do that, right? The setup logger. Run it again. Error. Inner bound 10 surpasses outer bound 8. On line 6. 1, 2, 3, 4, 5, 6. It thinks it's 10. Why would it be 10? It should be 2. I think I know why. We said 4, and that parsed 4, and it added 4 plus 4 is 8, and then it added 2, which sets the limit at 10. The outer bound is 8 because we only gave it 8 bits to start with. So that means I'm like calculating the bounds incorrectly. So let's make a smaller test where we verify that a small bounded region is what I expect. So test like 1 bounds. And this will be test like many bounds. or several bounds. So one bound, just one thing, right? Let's test that that does what we expect. So we should have, we should be at offset 4 when we're done. There should not be an error. We should have only an X. X is not an error either. There should be a 1 because it's 4 bits. It says offset 0, limit 4. And that's all we can claim. Let's run that and see what we get. Okay, yeah, so we have a problem with the 1 bounds. Okay, so on line 17. So it actually went to offset 8 for some reason. We didn't get a warning though. It just jumped ahead. I think I might know why, but I'm not sure. Hold on. What if we do that test last? Or is there an expect equal? I kind of wanted to have it like continue to see what other assertions failed. Okay, so it actually read the whole byte, not just 4 bits. So it's like that limit didn't apply, or the limit was miscalculated. Let's ignore line 21 and just see what the offset and limit are. Okay, it says that the limit is actually 8, not 4, but the offset is 0. Okay. So it's not setting the limit on X correctly. It's like I did a double add or something. Okay, let's walk through this and see. So the limit should be 4. So it should take the offset, which is 0, and add 4 to it and get a boundary of 4. Right? Update boundary should set it to 4. Execute statements should hopefully use a limit within the boundary. Oh, maybe that's what it is. Okay, that might be it. We might be ignoring that boundary completely. So we go into statement, we go into part, we go into, where is it? Ingest component, ingesting context. Then we go into ingest as UI, and yep, that's the problem. It's just going to the limit of the origin, not the bound of the context. Actually, this is context free. This is a problem. Okay, that's the problem. These ignore the context completely. What about ingest as custom? Does that ignore it too? Well, actually, there's one way I can find out. I can look and see where boundary is actually used. Find all references. If we never use it, then that answers that question, right? So here's it's declared. There's where we can get it. There's where it's set. It's set there as well. It's updated there. Okay, yeah, we never use it. We said it, but we never used it. Okay, well, that's unfortunate. So I know that then all of these need to be given that boundary. So let's do that. Let's solve that at first, at least at first. So context boundary there. So all of these will take a boundary, which is an optional size. Okay. They won't use it yet, but they'll at least get it. Right? The way we would use it, okay, this one needs it one too. The way we would use it is we would prefer this one, and if it's not set, we would use this one. Right? Yes. So let limit equal boundary unwrap or origin dot limit. Then this is just limit. There we go. So the same thing. Oh, wait, it should be limit minus the current offset, actually. Is this correct? Number of bits left. Wait. According to this, I should be updating this. Why did... Is the other boundary in the context then irrelevant? No, this comment is wrong, I think. No. This is correct. It's just not being set correctly. Okay, I misinterpreted this. So undo. By the time we get to the ingest, it should be set. It's just that we're not setting it. Correctly. Undid too far. Okay, there we go. So if I look at this, yeah, it's supposed to be pre-calculated to be the number of bits left. I think we're just not doing, we're just using the bit streams. Yeah, where is that set? It's when we make this bitstream subset. That's where it's set. So this final references. Make bitstream subset, yes. So where's that set? When we build a part, right. Okay. So then when we make this bound, we have to actually shrink it even more if if we're inside of a bound, if the context boundary is less, right? Hey there, buffer 0x8855. I'm debugging something in my parser right now. Yes, so bound is optional. I think it's in here we got to do our it's in this determine limit. I think I need to do it. Yeah, it's this junk, right? It takes the current offset and adds a limit to it, but this limit might be too many. In fact, it's this inner, actually it has an outer bound. Where does it get the outer bound from? Self-bound, oh, there we go. That's what it is. It checks if it blew the bound, but, yeah, so it is using that boundary. I didn't see that before. Is that the only place where it uses it? No, it uses it in a couple of the, well, that's where I was adding it. Okay, now it makes sense to me what I did wrong. We check to make sure it doesn't blow it, but we don't have we don't restrict it back. So yeah, originally I thought that we're only checking to make sure, but we actually want to limit it. So I do want to do a map then. Yeah, I do. Except for we could return an error. Okay, so yeah, this would be okay limit dot map limit to um, and then I'm struggling with the combination of option and result here. Let me take a drink. It's because if we're inside a function object, this return doesn't return all the way back out like I think it does. It just returns out of the map, right? So then, yeah, I want to do an and then. So it's limit and then. If we stretch it beyond the bound, it's an error. Else, it's got to be the what am I trying to say here? No, this is wrong. I'm not doing this in the right place. Damn it. Okay, this is wrong. Undo. Go back to the way it was. It was fine. For our test program. Okay, let's undo this. Let's go back to where we were testing this, right? This one. It's failing and saying that there are 8 bits to the limit to the offset here. And if I comment that out and I comment this out, it's going to fail on this line saying the limit is 8, which is wrong. It's 8 on line 23. The limit is 8. It shouldn't be 8 because we set it to 4. And so it should have set, the boundary started at 8. This should have rolled it back to 4. Somehow it didn't do it. Yep, we're in a virtual machine. So I think actually then the problem more is that the rollback of the boundary didn't work. So that was where in statement? Bound statement. So we get the boundary, which is 0 plus 4. We set the boundary to 4 instead of 8. Then we execute that statement that parses an integer. It should have yeah, this should have worked. Then why isn't it working? Let's do a debug of actually what happens if I do a debug of the entire context? Will it let me do that? Yeah, I guess so. Let's see what happens. I run this. So now right before it executes the statements, we get to see the whole context printed out. Some boundary of 8. Okay, so that it shouldn't be 8. It should be 4. We should have parsed a 4 out of this, right? So the bug is we're closing in on the bug. It should have been 4. It's not 4 there. Why is the boundary 4? So let's debug these, I guess. And this, to see which one is the wrong number, or maybe both of them. I could also just run the debugger on this. Maybe that's easier. Okay. The offset 0, the limit is 4. Okay, then I think I'm going to use a debugger because this doesn't make sense to me. If the offset's 0, and 0 plus 4 should be 4, not 8. Okay, we're gonna use the debugger. So set our breakpoint there, and then debug instead of run test, and we'll. Something I rarely do is run Rust code in the debugger. Okay, so then step over, I guess, and then so limit and boundary are 4, right? So context has some 8 in it. We go over, and now it's some 4. Original boundary is 8. Okay, and then step in, execute statement. We have an X. Oh, we can't actually see the collection. So I went too far, but I can see within the context, the composite's origin. Okay, wait, it didn't execute it yet? Wait. Oh, all right. Okay. Confused. Why didn't it put X into the composite? Why didn't it advance the offset? Oh, it doesn't advance the offset there. It's in this bitstream that it does it. And we can't actually see that. All right. So it probably read right past it. So let me stop and run again. Because we went too far. Okay, here we are again. So execute statement, step in, and then step into execute statement. Okay, set current span, that's fine. Let statement, it's a part statement, so execute the part statement. Build the part, ingest the component. Oh, went too far. Went too far again. I should stop there. So go back, debug again. So hit go. Now we're ingesting the X. So step in. Yeah, boundary's still at 4, not 8. Good. Out and then in again. Here we are, ingesting context. We have a format. We add it to the path. We go into UI. Let's put a breakpoint here in case I need to come back here. All right, now the bitstream, the origin limit is 8. Oh, we didn't update the origin. Okay, I think I might know where this is then. Tricky. It's when we build the part. That's ingestion. Ingest component context. Okay, we're already too far when I get that far. Let's go to statement, part statement. I think it's build part where the problem is. Yeah, it's this bound. Because that'll be none. Right. And then it goes into the determine limit. Bound will be none. Right, and then it goes into here. The outer bound, wait, no, okay. I need to put a breakpoint here then, because it should have gotten into here and said the outer bound is 4. The inner bound, oh wait, the inner bound is no bound. So what's the default if there's no limit then? So go back. What if the limit is none? Because that's the option. So, oh, here it is. The bug's here. The limit is none. And what it does is it does the rest of the bits, but it should do the rest of the bits, whichever is lower. Actually, it should just use the outer bound. So this should be given an absolute limit. It shouldn't be given an option. Yeah, this needs to be always. There needs to be a limit always. So we don't need to do that, which means we don't need to calculate. Actually, it's much simpler then. We still need the offset, because the offset we get from the bit stream, but we don't need this limit anymore. We don't need that. The limit is passed in. The offset we get from the bit stream's current offset. Okay, and then I just need to track the errors back then. So here it is. So we're in context. So this limit, if it's something, we use it. Otherwise, so we do unwrap, or we do self.boundary. Actually, and what if that's not something? Then it defaults to the bitstream's limit. So then we have to do unwrap that one, right? Well, unwrap. It's another one of these unwrap, right? Unwrap or else. We have to do an inner one, right? Unwrap or else. And then in here, we have to actually take the bitstream. So let, well, actually, it would be the bitstream's limit minus its current position. So that's origin limit minus well, wait, wouldn't it just be origin limit? Wouldn't it just be that? It should be that. But I had this bug the other day where like it's not supposed to be an absolute limit. We have to subtract the offset from it. But this should be doing that. And it was before, and I changed it. What was it before? It was that. So it is the number of bits left. So I do want to redo that. Yes, and then go back to, or forwards, or wherever. I need to go to wherever we call this. Here. No, not here. Here, yes. And it's not that, because that is an absolute position. So this does need to be an unwrap or else, because we need to compute it from that minus its current position. So that minus origin bitstream borrow offset. There we go. I think that did it. But to make sure, I want to track down all uses of this. Yeah, because we have two other places where it's a problem, right? So in ingest, that one has no outer bound, right? So maybe I do permit a none there. and I use a sum here and put this back to accepting a none and doing that. Length method minus offset. Yeah, okay, well, I think we'll do it that way. Because these ones, like, I need these ones to be like they are. Yeah, okay. Good, 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 good. So this has to say, like, sum. Like that. Pretty complicated. So there is some limit to the bit stream sum subset. And what it is it's the given limit. If it's not set, then we go to the boundary. And if there's no boundary set, then we take the actually then I can default it, right? Yeah, then actually I don't need to do this unwrap or else. I can just say this. Then I don't want to put the outer sum in there. So it should be limit or that, right? Because or returns another option. Yeah, limit or boundary. You know, it usually is the case that the simplest is the correct answer, right? Bound, run test, please pass. Yay! Okay, and then will the other one, this is the true test. It fails. Oh, I should make sure that those other asserts actually pass in the original test. Yes, okay. So it didn't fix everything. Let's see where this fails. Are those what I expected? Inner bound 9 surpasses. Yeah, we did expect an error there, and then we get a warning, skip 2 extra bits. That's correct. Okay, but then there's a 6 instead of an 8. Limit or self-bound. Is that what I ended up doing? Yep. Japfo had it. No, I'm not. Your comment was correct, Japfo. So, points. Japfo. You get a point. I should have listened to you, but I was too wrapped up in what I was doing. I don't know what I'm doing with my shells here. Let's just run this again. Okay, it's on line 46. So it's the offset that we get to when we're done. It should be 8, but it was 6. So I think what happened is we didn't skip the extra bits. Yeah, on error, we didn't skip the bits. We have to do that, right? In fact, we should just do it unconditionally. We should set the offset past the bounded region, whether it was a success or failure. Okay, statement, right? Execute bound statement, right? So here, this would have had an error, right? So it should have just gone back past it. Why didn't it? Okay, then I don't understand why it didn't work. In fact, we should have gotten a warning even for the error. Try again. Look more carefully. This makes me want to step through it just to see it. Now that I've had a good experience with the debugger. So we'll put a breakpoint there and remove that one. Where's my deep? Here it is. Actually, let's just clear all of these. What happens if I hit that? Okay, that we're good. Okay. Bounds debug. Where are we? Let's try that again. I guess we panicked? How come I can't click on that now? I broke it. I broke it. Oh, no, there it goes. Why are we... Why? Oh, I removed my breakpoint. That's why. Shoot. Put the breakpoint back. In statement. Here. Now run. Yes. Okay. So we want to watch the offset, which is boundary, right? Offset plus limit. So the boundary right now is 4 because the limit's 4. Go again. Now the limit is 2 and the boundary is 6. Go again. It never parsed it. Wait, why? We had 3 bound statements. Did it end early? Problem is I don't know which one it went into. What if I make that a 1? Then I know the difference between this statement and that will have a different bound. We can see which one it actually went into. So I have to change some of these things, right? That should be 7. This should be 5 with a limit of 1. And the bit it will actually parse is different now. It will, no, it's still 0. Actually, let's make that as 1, 1 so that it will see that 0 bit and not the 1 bits around it. Okay, then go again, debug. Okay, so boundary 4, limit 4. Boundary 5, limit 1. And it never got to the third bound. Oh, did it error all the way out? Yeah, that's right. I wanted to specifically contain an error within a bound statement. Right now, this error is just causing it to stop. I think we want to say, well, we'll stop, but we'll get out to a bounded region, and then we'll say continue from there, because we can reset the position. Okay, I know what to do then. So statement, basically, we still do this, but we only warn if the if the return scope is not error. Because if it's an error, then we're always going to jump. Really? I didn't mark it as derive. We should just derive all the useful things, right? Debug and partial equal. And shouldn't we just always do copy and clone? Because it's trivial, right? Okay. Technically, clone comes before copy alphabetically. All right. So the other thing is that I want to squelch an error, right? So we want to do a match on it. An error goes to a next. And what should a break do? If we're in a bounded region and we hit break, it should be a break, right? Should an error upgrade to a break and not a next? It certainly shouldn't be a return. No, it should be a next because unless there really was a break statement in there, if there's a boundary region after it in a loop, then we need to get to it. Okay, so then it's return and next that both fold into next. No, sorry. It's undo that. It's error and next fold into next. Next or error. And then return stays return. There we go. Okay, now we're trying again. Run this test. Should be no change. And then run this test. Still fails. Okay. The offset wasn't 4. For Y. Oh, do we just never set it? It was a none. Oh, the origin isn't set on Y. Why wouldn't it be? Oh, because yeah, it doesn't know where. Well, no, but I wanted it to know where it was at least, right? Yeah. Okay. So then, I should update it so it should set the origin. It should set at least the offset, but maybe not the limit because the limit's bad. Okay, so we're updating. Where exactly would that be? That would be where we saw that outer bound. Outer bound. This thing. So it's the call stack of this thing. Call hierarchy. Right, not there, but here. Make bitstream. Yes, exactly, right here. We should always make one, right? But have the limit be 0. Okay, so then how do I change this? If even on an error, this determine limit, right? I do want to remember that it's an error, but I also want to have a bitstream subset. I guess it depends on how this is used. It's used in build part. It's used to assemble the origin, which is correct. We want it to go into the component. Okay. I mean, I could do something cheesy, and I can take this and put it on the other side too, like this. That's really cheesy. It's saying you get a bitstream subset even if it was an error. Hold on, I'll be right back. How to do it. I thought about how to do this. So it's not that I want the result to carry that. It's that we're going to return a tuple and we're just going to move this out of here. So this moves out there, and we have a result that we use to indicate if there was an error. But if there wasn't an error, there's no information. But we always have possibly a bitstream subset. So then determine limit is actually going to return something like that too. Because determine limit can error out. But even if it errors out, we want it to return what these limit, what limit we want to report back. So yeah, that means I'm moving this out to there, making that. So that's a very odd return type, but yeah, we can deal with it, right? So if we have no bound, okay, so if we have a bound and it's erroneous, then we want to turn it to okay, we can't use the question mark operator I can't use the question mark operator anymore because it's a tuple. So I need to split this into two pieces because we're doing the flatten afterwards. Okay, and then rather than doing that question mark, it's let okay of that equals that else. Return. Well, then actually then it's a I want the error out of it. Oh, then it's the other way around, right? Crap. No, it's not. Shoot. Well, the error is going to be a sum 0. And then I need the error there. I guess that is a match, right? Match. So yeah, then there's an outer let value equal, but then it's this match this to if it's okay value, then we unwrap it to the value. Really need to go to bed because I'm starting to really mistype stuff. Yeah, it's just this, right? Yes. And actually then, yeah, error. Actually then I don't even need this, right? It's just error. Expected result found enum result option. Whoa. No, I need to map the error. So yeah, turn this around. It's just ingestion error. Well, it's the error part of that. Yeah, okay. Yeah, the type does change technically. This type is a much bigger type than that. Okay, but then I can do the flatten outside of it. It's not too bad. All right, and then I got to continue it the same way, right? I have to do a match that. where if it's an okay limit, it's limit. We have a value, so we want to, I want to repeat this arm again. So basically I'm reducing the limit to 0 and also indicating that's because there was an error. Okay. And then if we have a limit, then what we return here is some 0 with that in it. Otherwise, it's this and it's limit and okay with no value in it. Very odd return value. I'm sure I'm gonna raise all sorts of objections from Rust people. It's an unconventional return value. How we map this thing? It's a limit with an error, well, a result. To that with the result in it. And it's not a map, is it? It should be because it's a tuple, we just have to say this, right? Limit result equals that, and then I have to do that comma result. Like that. Okay, one more place. Okay, yeah, it's let's just do it one piece at a time. Let origin result equal that. And then it's going to be origin unless result, right? That's an odd way of saying it, but it works. Oh wait, we're inside build part. I actually want to build the part and not break out, right? Oh, then this actually moves this out, doesn't it? Hold on. Yeah. Okay. That infects this again, right? Yeah, because yeah, okay. Yeah, let's do it. The same quirky stuff, we're gonna do it again. So we're gonna get the data with components as always, and then along with it, there's gonna be indication of an error. Actually, then why don't I just bake it into the error flag of that? That makes more sense to me. So we just always return this, right? And then the way we'd get this is we would always, yeah, we'd always return one of these. So this, in this case, it would be return data components with arguments. Component is data component new error and statement format and origin, right? In this case, we don't have an origin, so it would be none. And arguments are args, right? Okay. And then here's that result, right? So it would be if result. No, okay, then. Okay, I'm doing this wrong, actually. We should just make the component with its arguments right away. But if we can't build a statement, what would we have done before? We would just end up making something without anything in it, right? No arguments, right? Well, yeah, we're not gonna we don't even go into ingest if it didn't. Yeah, the arguments are never used. Okay, then that answers that question. Okay. We're always going to make one at the very beginning. Let mute data with args equal basically this. Paste. We don't have arguments yet though. So that's going to be an empty vector. Oh, this is horrible. Do I really want to do it this way? Wait a minute. Yeah, it's just going to return it at the end, right? Yeah, this is putting the cart before the horse before the cart, right? This is all messed up. Go back up. Okay. Yeah, we have a problem with there, and we have a problem there, and this we don't have a problem with. Okay, I'm gonna undo even further then. Yeah, I'm gonna undo back further. All of this just because I want to get to make one of these early. What if I do that earlier? Because I don't have to do the arguments here. I could have done it down here. The arguments aren't used until down there. That would make it simpler. Yeah, why don't I do that? Yeah, we won't bother. We're not going to bother evaluating the arguments if the bound is bad anyway, right? Or maybe I do want to. I don't really care though. No, we're just going to put that there. Okay, and then yeah, I think then there are two possible ways to flag an error. Either it's an error outright, or we assemble a component where the error flag is just set right away on it. And that'll be on this right here. If this fails, it's definitely an error. If this fails, it's more of a soft error, right? So that means I need to remember if it was bad limit. So this should go to origin none false. And this should go to origin comma result is error. So it's a soft error. And then I guess I need another constructor because I need one where I can set the error flag. I can actually make it and then change it, right? So let's do that. Let mute component equal that, and then component dot error equals bad limit. There. It's just now build part could succeed, but with having an erroneous part in it. So I think that's where I want to check here, only if it's not an error. Yeah, if part with args dot component dot error is not true, then we'll ingest the component, right? And then what does ingest with component do? That's right. It's whatever this returns. I need to return it. Data component and return scope. So it would just be this. So if it's an error, it's gonna be that with a return scope of error, right? There we go. Got one more error up here. Okay. Okay, so we have to change this around, right? Because we always get a limit out. So let limit result equal this, right? And then it would be if result is error. Okay. We're good to go. I need to go to bed soon. I'm getting tired. It's 1 in the morning. What am I doing staying up so late? Hey, we passed our test. And yeah, we get the things we expect. So the inner bound surpasses the outer bound, and then we skip 1 bit. Cool. All right. And then let's do cargo next test run. Cool, we're passing all the tests. Thank goodness. All right, so that was a real trip. So I had to do some really funky return value finagling to get that to work. So let me review that, and maybe I'll learn something about what I did. So a bound statement, right? We have to have a bit stream. We can't set a bounded region without one. Hey there, TS Just. Hey, we got it working. Have you been here all along, just like nervously clinging to the edge of your seat to see if I would figure this out, or do you have me in the background? And you don't need to answer that. So if we have a bit stream, then we determine the limit for the bounded region. And this is where it gets funky, because this is a statement saying you're always going to get possibly a limit, but in addition to that, we'll tell you if we had an error determining it. The reason for that is if we get down to one of these conditions, we want to tell you that we would have given you a limit, but it's an error, so use 0 instead. As opposed to that Actually, if we're always doing sum 0 for an error, then what's the point? Maybe I could have simplified this. Maybe if we return an error, then you should assume sum 0. I guess I was thinking if there was no bound but there's still an error, but I don't think that's actually possible. Yeah, I think maybe this is just because my brain is addled. If we're returning an error and sum 0 is what you should expect for error, then I don't need to make that separate, do I? Hold on. So maybe I clean this up by doing it the right way, which would be, yeah, that would allow us to totally make this nicer, right? To go back to what it was. And then actually this comment will be correct again. So can I undo, but only undo some of it? No. Okay, we can repair this. So statement determine limit is actually we're going to move this back because I just realized that we can conventionally say that if we get an error, use a sum 0, right? So then this goes back to just being transpose question mark, right? Dot flatten. And then again, this becomes value map transpose question mark. And then this is just returning an error. And this is saying okay limit. Back to something reasonable. Okay. That means that let so in this, no matter what the result is, we're forming a bitstream subset, right? So I think we keep this the same, but I want to pull apart. Okay, yeah, so let result equal that. And then we independently set limit equal to if, well, it would be result or unwrap or, right? Unwrap or sum 0. There we go. Oh, but we consume result when we do that. Shoot. So we can remap it, right? Hold on, we can make this newer, better, stronger. So I guess that means we're rewriting what result is. Hold on, then wouldn't it be easier to do this way? Result and limit equal to match. And then open up the arms there, and then this is a limit. And then we don't care about that error, do we? Actually, we do care about that error. If it's a limit, then we get a okay. Actually, let's turn it around to limit result because that's sort of mirror. Well, it doesn't matter. okay, and then the limit is limit. If it's an error, then here's where we put in the error, and then we put a sum 0 here. I think that's what I want. So this takes one result and expands it to provide if it's a limit, then we signal we're okay. But if it's not okay, we fill in a default, and we've stripped out the success of that. We basically pulled it out so that we always get a bitstream subset, even if there's an error, but we signal an error separately, so that we're always creating something there. So then I can actually turn this around. Hold on, I gotta let the dog out. She's like barking. Okay. Actually, these being separate is okay because I could no, I would have to put that on both of these. So this is better, right? Although some 0 will always be 0 here. No, but then I'd have to copy that twice. Okay, this is fine then. This is fine. We're all fine here. Okay, and then this can be simplified again, right? I forget what this was before. I can just hit undo then. Okay. Okay, let's see if that should still work, right? Yep. Okay, so we're good. All our tests pass. That's all I really care about. The tests give me confidence that it's correct because they're pretty exhaustive right now in this bound statement thing. So let's now we'll review it one more time and make sure I'm happy with it. So we'll make sure that there's a bit stream. We determine a limit based off of the bit stream we have and what bound we want to set on it. And what that does is make sure that that limit makes sense, and it's not a bit bigger than the outer bound. And if that's okay, then we continue. Otherwise, it's an error. Okay. If there actually is a limit, then we're good. But if there isn't, then it doesn't make sense because that means we have a bound statement with like an empty bound. Doesn't make sense. Then we take our current position, add that limit. That's the new boundary. We put it in and record the original boundary, which might not have been any at all. Execute the statements, and then get the bitstream again so that we can see what the new offset is to see if we have extra bits. Then we advance past the boundary. If it's not an error, we emit a warning that we're skipping bits. If it's an error, it's sort of assumed that we're skipping bits because there was an error, right? Then we restore the boundary to what it originally was, and then we translate an error as if we basically consume the error. We will continue as if there wasn't an error. This is one of the only places that will allow that to happen because the bound sort of is a container that allows anything inside to be erroneous, but then we can continue going. Actually, the problem with that is that we might not know that there was an error deep in the bitstream somewhere. Rather really continue parsing and then set the error flag anyway. Hold on, I gotta let the dog back in. Getting to where you do not hate to see the borrow checker's output. Does that mean you're getting better? Yes, it means you're getting better. But it also could be that you're skillfully avoiding the really hard, like more advanced, like tricky things. If you get overconfident, you'll find yourself like, oh, I can do this. This is easy, and then the borrow checker slaps you on the wrist. Yeah. So if we return an error into a next, we're kind of hiding the fact that there was an error. So maybe what I want to do is when we assemble a composite, we should make sure that no component actually has an error. Actually, it's not make sure. We would see if any of them has an error, we would set it on ourselves and return back out. That's probably the right thing to do. Yeah, we can set the error bit independently of the return scope. That's how I'll do it. Okay, so that we've set the error. Right, so the way we should set the error on the outer is that if any inner has it set. Okay, good. So the other thing I wanted to check was if we're executing a part, right? Part statement, right? And we say, well, build the part, and here we get the origin, and we say that there is a bitstream. Then we're going to try to make a bitstream subset based off of the bound expression. Here we go, right? First, we're going to determine the limit we should have based off of the bitstream and the bound. And at any of these points, we can have an error, right? It's misspecified. If at any point it's misspecified and we get an error, then we keep the error, but we actually put in a default 0 limit so that we can record the offset and the bitstream so that we know where the component would have been in the bitstream, right? But it has a 0 limit, and we separately return. So we always return a bitstream subset, but if it's erroneous, it's always going to have a 0 limit, which makes sense. And the result is carried independently back. And what we make of that is we always have an origin, but then if it's an error, we record that yes, there was a bad limit. We continue as if everything was good, but we set the error flag if the bad limit flag was set like right away. And we're still in building part, right? So we make it out of build part. It'll have error flag sets, so we check that here, and we go in, and if it's an error, we don't bother ingesting it. We return it, including its bitstream subset, but it's now return scope error at that point, so it'll error all the way back out. Yeah, I think that's fine. So if there's a part after it, we can't parse it anyway because we don't know where it begins. But if it's part of a bounded region, the bounded region will eat the error, right? And yeah, so we allow it to continue and not stop if we're inside of a bounded region, we just pop out of it. Okay, that works. And then that means that when we're doing the statements for a composite, so that's in ingest, right? Component, and then that has in context, and has a custom format, right? And we have all these statements, execute statements. We go into that, execute statement. Execute part statement. Yeah, okay. We do set the composite error. Even if the return scope wasn't error, we still capture that error flag all the way back out. I should look. Let's make sure of that with a test. So the test would be actually, yeah, the test is that the foo should have an error flag set, and it passed that test. Great. Cool. Yeah. So the only way that this actually works correctly then is this is the erroneous block. It still is able to parse the Z, but foo has the error flag set. We tested all of those conditions, so I think we're good. So we did well, chat. We deserve to have a purring kitten. Purr into the mic for a little bit. Yes, she says well done. Now she will go feast. Okay, cool. Let's send this out of the virtual machine, and then I need to wrap up the stream and get some sleep. I'll probably be going tomorrow. Let's see, what am I going to be doing tomorrow? The next to-dos? 13 left. So ignore statements. Actually, that's almost exactly the same as a part statement, only we don't have a name and we don't store it. Right? Then we have the for loop, which is like a more advanced version of the while loop. Assign, accumulate, increment, decrement, those kind of all go together. So yeah, binary operations. Actually, that's probably what I'll do next is the binary ops. Or functions. Function is like a part, only it has no bit stream. That might be fun. Map set. Oh, we have to do vector context. Yes. Also, I need to be able to reference vectors, right? If a value is a vector, you should be able to index it. Yeah. Actually, what happens if there's a vector inside a vector context? That makes it a two-dimensional vector, right? Yeah, okay. It all works out. So, yeah, she's going to torture the dog. She does that all day. I think right now she feasts, and next she will be trying to eat my foot while I walk upstairs. While that happens, let's go watch someone else. Wow, there's absolutely no one streaming. It's because it's 1:35 in the morning on a Sunday morning. That's why. Good night, TS Just. Hey, TS Just, who should I raid? I don't know anyone. The only one I know who's streaming right now is a pixel artist. Not saying that a pixel artist is a bad stream to raid, but I'd like to have more than one choice. Who's Dev Spagus? I don't know this person. Let's see. They have a broken stream right now. Looks like they just went offline. Should I look at who else is in Pirate Crew going? It's just ferret software. Literally a ferret. Okay, well, that was an F. Yeah, they just went offline too. Good thing they didn't raid me. That would have been embarrassing. I'd like get raided right at the end of the stream. Well, I guess I have no choice. I just have to hit the stop streaming button instead of the raid button. I'm sure you guys will find another stream to watch. Keep working for another hour and a half and raid Tim. I wish I could, like, say, host Tim so that when he comes online, you'd be watching him. But yeah, they got rid of hosting. All right, I'll probably be back tomorrow I don't know, 10 hours or so from now. See you then. Take care. Bye.